Good morning, everybody. Good morning, good morning. Can you mute the mic, please? All right. So the aim today is to work through this paper, January 2021. This was our last mock exam. People online can hear me? Can see the screen?
Yes, sir. Can hear you.
All right, good. And can see the screen okay?
Yes, sir.
All right, beautiful. All right, so what we're doing today, we're basically working through this paper, and we want to get a grade at the end of it. All right. At the end of working out this paper, I'm proposing that we continue what we started last night, which is to do topic by topic a few more questions. So maybe we can cover 2 more topics today. Maybe functions, maybe quadratics, maybe the pattern question. I don't know. But at the end of completing this paper, I propose that we do a couple more questions. For tomorrow, we had scheduled tomorrow for 9 p.m. Some persons are proposing that we basically just start the session with our regular class time at 5 o'clock tomorrow and do the same online thing and continue until we basically finish all the questions on those 6 papers that we're doing, right? Inclusive of question 1 and question 2, all the questions. And that will serve as basically a full complete revision for the exam. Right? What I don't want is for us to skip out something and then we'll see it pop up on the exam. Something similar to what is on one of these papers. So it's best we just find a way to complete all of it. So I'm suggesting that we start, instead of 9 p.m., start at 5 p.m. tomorrow, which is Jamaica time, 5 p.m., 6 p.m. Trinidad and Tobago time. All right, so what I'll do, I'll send back out that invite, that invitation, and I'll change the time to 5 p.m. All right, so we'll come here at 5 p.m. We'll do the same setup and we'll continue. All right, some persons who can't come can stay at home and join online. All right, so let's get cracking. So working out this 2021 paper, I'm gonna work from front all the way around, from number 1 all the way around to number 10. All right, so we're going straight into it. So the first question is right here. This is your usual question where they are telling you that you can use your calculator or otherwise to get the exact value of this. And I'm saying, since you're telling us to use a calculator, we can use the full capacity of the calculator. And I suggest that we all get one of those textbook display calculators so that when you type this in the calculator, it appears exactly as it is there. So ensure that you enter the correct thing in the calculator. So this is my calculator on this side. So I'm going to enter that expression, right? And work it out. So first is a mixed number, 1 and 4 over 7. And then I'm adding a fraction 2/3. And then I'm subtracting another mixed number, which is 1 and 5 over 6. And I ensure that what I have here is the exact same thing I type in the calculator there. All right? Oh, this up the screen cover it. Let me get it off the screen. One second. Let me get it off the screen. All right, and calculator gives us the answer here as a decimal, but your calculator can also show it as a fraction to get the exact value. So that's 17 over 42 is the answer in the lowest one. That's the exact value, 17 over 42. So I'm just going to write equals 17 over 42. And that's it, done. All right, so that's like 2 free marks. Just ensure that what you have here is the exact same thing you type up here in the calculator, which is correct. All right, that's all. Next question. They want us to write this as a fraction in lowest term. Again, we can put it in the calculator now and see what it is now. But we can also work it out. This is the cube root of 27. So this is equal to the cube root of 27 is 3. The cube root of 27 is 3. And it's 9 times 9 is 81. But because I want to simplify it, I'm going to write it as 9 times 9. And then 3 into the 3 here is 1 time, and 3 into this is 3 times. So we have 3 9s 27 under here. So it becomes 1 over 27. But again, we can put it in the calculator just to make sure that it is correct. So I'm going to just type this exactly as it is in the calculator. So it's a fraction, and it's a cube root of 27 divided by, that is 9 squared. And look at it as a fraction, and so we get the same thing here, 1 over 27. So this is correct. All right, but we'll show some working here because it did not say use a calculator. That's how we'll show some working for that one. All right, where this one said use a calculator, I don't need to show any working. Just put it in the calculator. All right, that finishes those two. Moving down to this question. All right, so let me take this off a bit. So this question says the thickness of one sheet of cardboard is 485 times 10 to the minus 2 millimeters. It says a construction worker uses 75 sheets. Now one sheet is this thick enough. And we're using 75 sheets of the cardboard stacked together to insulate a wall. And question now is show that the exact thickness of the insulation is this. So essentially, we just need to multiply the 75 sheets by the thickness of one sheet. That's all we need to. All right, so we just need to show the working. So it's 75 times the 485 times 10 to the minus 2. And if you work it with the calculator, it's going to be equal to this. The 363.75 millimeters. That's it. So this is the calculation you're looking for, that you multiply. You want to show it on the calculator? Then we type it in, and it will be 75 times 485 times 10 raised to the power -2. That's it. Same answer. All right? Well, that is that. Next part says, write the thickness of the insulation correct to two significant figures. So I want to write this correct to two significant figures. So let me write again first. 363.75. So the first significant figure is the first non-zero value from left to right. And you want it to two significant figures. Now remember, the magnitude of the number must not change. The size of the number must not change when you finish. This is in the hundreds. So your answer must be in the hundreds when you finish. All right? So the two significant figures are these. The first two significant figures are those. So using this 3 to correct that. It cannot increase it. The 3 cannot increase because of value less than 5. And so the 36 remain, and then everything after to complete the number of decimal places that you want, or to complete the size of the value that you want, will become 0. So this becomes 36. This becomes a 0 because it's in the hundreds. We don't have to put the 0.00 in. We don't have to. So we can leave it as the 360. All right? We can leave it as the 360 millimeters. And that is what it is to two significant figures. To two significant figures. Two significant figures. That's what it is. This is the answer to two significant figures. All right? If you want to put the 0.00, no problem. Still correct. All right? So that's two significant figures. Next, they want us to correct it to one decimal place. Let's look at it again. So it's 363.75 and I want us to correct to 1 decimal place. So this is that 1 decimal place value right here, 7. Using this 5 to correct that 7. The 5 will increase the 7 by 1. And so the result of this to 1 decimal place is 363.8 millimeters to 1 decimal place. To 1 decimal place. And this is the answer to 1 decimal place. Very good. Nice and easy. Next part wants us to write it in standard form. So let's write about the original number again. 363.75. And in standard form, what it is that you want the decimal point to go here. You want to have 1 non-zero digit before the decimal point in standard form. And then it's multiplied by 10 to some power. 10 to some power. Now remember, this is a large number. It's a relatively large number. Right? So it's going to be 10 to some positive value. Right? It can't be 10 to the negative value. Because 10 to a negative 4 means it's a decimal point value, a small value. So how I normally say we can do this is adjust it. We want to adjust it to move the decimal point 2 places to the left. So if we want to move it 2 places to the left, we will divide it by 10 squared. The square here, we move the decimal point 2 places to the left. And to cancel out the multiplying of that, the dividing of that by the 10 square, we multiply back the result by 10 squared. So we cancel this division by that multiplication. And then what you do, you use this operation right here now to move the decimal point for you. And this comes back as a part of the answer. All right, so basically they're showing some procedures, a process of working. So it becomes 3.6375. That's what this gives us. And you put back this as a part of the results, times 10 squared. And that is the answer right here. In standard form. Another name for standard form is scientific notation. So instead of saying standard form, they could have said scientific notation. It's the same thing. Standard form is scientific notation. So that completes that question. All right? Then we come to this part now, this exchange rate question. Remember, exchange rate questions can be done as ratio questions. You can do them as ratio questions, where you multiply and divide by values to get what you want. So this question says, Marco is on vacation in the Caribbean. He changes 4,500 Mexican pesos, which is, this is it, MXN, to Eastern Caribbean dollars, ECD. And he receives 630 EC dollars. So the 630 EC dollars is equivalent to the 4,500 pesos. And I want us to complete the statement below. So essentially, we want to know what 1 EC dollar is. So we need to write the relationship first. To show some work, we're going to write the relationship. The 630 EC dollars is equal to 4,500 Mexican dollars, or Mexican pesos. If you want this side to become 1 as it is there, we just need to divide both sides by 630. That's all we need to do. To get this side to become 1, we divide it by 630. Divide this side also by 630. And then this now, when it becomes 1 right here, whatever this is goes there. So it's 4,500 divided by 630 or 1. 4,500 divided by 630. All right, and we're getting 7.12. 7.14. So I'm going to put the 7.14. Because it's money, right? Because it's money, we're going to put the 2 decimal places, right? So it's 7.14. You don't go more than that. That is it. 7.14 Mexican dollars, approximately. But I get that? Beautiful. So it's 9 marks for that, you know. Easy 9 marks for question. Everybody should get that 9 marks. Correct? Correct. Next question, number 2. So number 2 is what it normally is, your factorization and so on, right? So this part wants us to factorize this completely. Complete means that when we finish factorizing it, no part of it should be able to factorize anymore. You should not be able to factorize any factor any further when you finish. Since I see 2 terms there, generally speaking, you look for a highest common factor first. And then because I have the minus sign here, I'm also going to look to see if possibly we have the difference of 2 squares. So looking for the highest common factor first. Let's put that equal beside it. In terms of the numerals, the highest common factor is a 4. 4. In terms of the n, the highest common factor is just n. I have n squared here and n here is n. In terms of the m, there's no common factor of m because there's no m in this term. So this 4n is your highest common factor right now. So the factorization really is dividing these values by the 4n. So if you divide this 12 by the 4, you're going to get 3. You divide the n out of this n squared, you're going to be left with n. Then you divide this negative 4 by the 4, you're going to get back negative 1, but don't put the 1. The n is factored out. This n is factored out here. And the 4 is like a factor out the 4n. So it's here. So all we left inside here is an n. And you can double check it by expanding back this to see if you get that result. And this is what you will get. Then you check inside here. Can this be factorized any further? No. And so that is the answer. All right, we got pains to explain it, but you know, that is it. Sometimes you can just write it down. Easy. We just basically try to put some explanation for the purpose of the class. All right. This question says we must show that this thing equals this thing. So what they wanted to do is take this thing and convert it into a single fraction. That's what they really wanted to do, and show that that is a single fraction. All right. So I'm going to call this the left-hand side equals the right-hand side. So I'm going to say the left-hand side is x divided by 1 minus x minus 4x. Now, when I'm adding values that involves fractions, I want all my values to be related. I want them to be related fractions. They are related when the denominator is the same. So I want to adjust this 4x to make it have the same denominator as this one. Easy way to do that is to actually divide it by the 1 minus x and then multiply it back by 1 minus x. So like you divide it by the 1 minus x because you want 1 minus x on the here, but then you multiply it back by 1 minus x. All right, so what you divide it by, you multiply it back by the same thing. So essentially, you have not changed the value of it. You basically just changing the appearance of it pretty much. All right, and then you work this out now. So this stays at x over 1 minus x. Minus, that's this minus. And I'm going to expand this up here now. So it's 4x times 1 is 4x. And then 4x times negative x is negative 4x squared. Negative 4x squared. And you're dividing that by 1 minus x. Now, since I have the same denominator, I can work the numerator value. So it's this numerator minus this numerator. All right? And you do the like terms. It's going to have a common denominator of 1 minus x. Then it's x minus 4x. X minus 4x is negative 3x. That's negative 3x. Negative 3x. And then nothing, no square term, minus and negative 4x squared. Minus minus becomes a plus. So that becomes a plus 4x squared. Plus 4x squared. That's what I have so far. But this is the answer that I have now. So clearly what they did now was factorize the x out of these two terms. See? So we factorize the x out of those two terms. Out of this one, we're going to get the 4x that I have inside here. 4x. And out of this negative 3x, we're going to have the negative 3 that they have here. So we have the minus 3. And that goes back over the 1 minus x. And that was shown. That is it. That is it. All right? That's not the only way to do it, but that's good enough. A good enough way to do it. All right? Question now says, hence, solve this equation. Now the word hence here means that we must use this result. Use this result. And what it is that this expression, we know it is equal to this. So that it means that we're going to put this equals 0. All right? Because the hence method. So we're going to write the x bracket, 4x minus 3 divided by the x minus 1 equals 0. Now it's quite simple. If a fraction is equal to 0, then it is the numerator that is equal to 0. If a fraction is equal to 0, then it must be that the numerator is equal to 0. Another way to look at it is to say, if we take x minus 1 and multiply it across here by the 0, it's going to be equal to 0 just the same. You're going to be left with the numerator equals 0. But generally speaking, if a fraction equals 0, then the numerator is 0. All right? Let's undo this. So what if the fraction is undefined? What is equal to 0? If the fraction is undefined. The fraction is undefined, which means that that's symbol for undefined. Then it is the denominator that will be 0. All right? So in this case, we want the numerator to be 0. So it's going to be, let's put this back up here. We don't have a lot of space. Right up here. So I'm saying that the numerator will be 0. So I'm going to say that implies that the x times 4x minus 3 is going to be equal to 0. And that's a product equals 0. So if a product is equal to 0, then either this equal to 0 or this equal to 0. If a product is equal to 0, then one factor in the product equals 0 or the other factor equals 0. If this is equal to the 0, then the result will simply be that x equals 0. Or if this is equal to the 0, let's write it down. 4x minus 3 equal to the 0. What will be the x? Transpose the negative 3, get positive 3, and then divide under the 4. And so the result here will be that x equals 3/4 over 4. So those are my values. 0, 3/4 are my values. Very good? All right, beautiful. All right, next question. This question says we are to make V the subject. Make V the subject of this expression, or of this equation, of this formula. So basically, I want to transpose everything away from this V. This V right here, I want to transpose everything away from the V. First thing we want to move is the square root sign. The inverse of square root is square. So essentially then, what we want to do is square both sides. Square both sides to move the square root sign. Square both sides. So our first line is going to be that p squared equals 5 plus vt. That's our first line. You want to move this 5, bring it over here and subtract it. Same as saying subtract 5 from both sides. We're going to have p squared minus 5 equals the vt. Then we need to move the t. The t over here is multiplying. So to get rid of the t, we'll divide both sides by t. Cancel this t right here. All right? Divide both sides by t, or we can say shortcut to divide the t under here. So the v is going to be equal to p squared minus 5. Let's put some space on it. The v is going to be p squared minus 5 over t. Because they said make v the subject, we're going to rewrite this and put the v on the left side. Because they say make it the subject. Usually the subject appears on the left side of the equation. So when I say i.e., that is, the v is equal to p squared minus 5 divided by t. And I'm representing this as my answer. With v as a subject. Body good? Online and body good?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, that's pretty cool.
Good. So let's continue. This part now. I want to do the mathematics easily, right? This part says the distance needed to stop a car, the distance is d, varies directly. That's a direct variation. So this is saying d, the d varies directly. So we're setting up an expression now. D varies directly. When it's a direct variation, becomes equal to a constant times. A constant times the second variable. What's a second variable? It is square of the speed s. The square of the speed s is s squared. S squared. So this is our relationship. D equals a constant of variation times s squared. If instead it was inversely, if this instead was varies inversely, then it would be d equals a constant over s squared if it was inversely. Inversely. The question said inversely, that is what it would be. But this time it is directed, so it's k times. So this is our relationship. Now the question went on to give us some information. It says, a car traveling at 70 kilometers per hour, that's a S value, it's a S value, requires a distance of 40 meters to make a stop. So in other words, when the S equals 70, the D is equal to 40. That's what they basically saying. The 70 and the 40 go together as a pair. When the S equals 70, the D equals 40. They want us to say, what is the distance? What is the distance required to stop when it is going at 80? So in other words, they want us to know when the speed is 80, what is the D? What is the D when the speed is 80? Now this question can be done by finding the K first, by plugging in these values in this relationship to find the K first. We don't need to find the K first, because the question did not ask us for the K. So I'm going to show you how you can do it without finding the K. Right? What you can do is make K the subject of this relationship. So basically what happened, let me put in a different color now. From this relationship, the K is going to be equal to, and the K is a constant, the K will always be equal to D divided by S squared. So it's a D over S squared is always constant. D over S squared is a constant at all times. That's what we basically say. So D over S squared with these two values will be equal to D over S squared with these two values. That's what it is now. Right? So we're using this relationship. And the D over S squared is always the same. Bring it the easy way. So I'm going to use these two first and put D over S squared. So the D over S squared using these two would be 40 over 70 squared. So this pair is D over S squared, this pair. It will be equal to the same K for this same relationship. The D that we want over the 80 squared. That's it enough. Because this equal to K and this equal to K is 2. So the K is a constant. I just need to calculate the D from this. This is the answer that we want when the speed is 80. So to get that, I just take this D squared and multiply it up here. Right? When I multiply it up there, I'm gonna get 40 times 80 squared over 70 squared equals the D that I want. I wrote that out. All right? And let's see if you all got the same answer. We could have done it by finding the K first. We don't need to find the K first because the question did not ask for the K. We need to recognize that the K is a constant. The K is always equal to the D over the S squared. So for one situation, D over the S squared will be equal to D over the S squared for another situation. That's how we set up. All right? And I was solving for the D. So basically, we put in the calculator to be 40 times 80 squared divided by 70 squared. And answer is 52.2. So D equals 52.2. So if you did it by finding the K first, that's fine. So the D equals 52.2 meters. And it was distance was in meters, right? The distance is in meters. So make sure you write it. The question asks for the distance. So it's 52.2 meters. You cannot show it 52.2. So the answer is 52.2 meters. What do you do with that? So if you did it that way, we find the K first and get the formula fine. We have to show you how you can do it without finding the K. K is a constant, right? K is a constant. If it was an inverse variation, I'm going to show you. If it was an inverse variation with the same value, then what would happen is that the D would be equal to K over S squared, right? And if you multiply the S squared over here, then the K would be equal to D times S squared. And so the D times S squared will always be the same value. If it was an inverse variation, this is what you would have. So then you could use the same values and say D times S squared up here. So the 40 times the 70 squared for this pair will be equal to the 80 times the D squared for this one. So that The D times 80 squared will be D times 80 squared. That is it. And that's why you will solve for this one if it was an inverse variation. Because the K is a constant. The K is always D times S squared. So the question don't ask you for the K, you can do it this way. But if you're comfortable finding the K first and so on that we did in class, no problem. But I did tell you that I was going to show you how to do it without finding the K. So this is it. All right? So no problem. That is the answer anyway, in any case. All right. Let's continue. So the answer is 52.2 meters. Why did I put 0.2? Why did I put 52.2 and not 52? Because if the question does not tell you how accurate you must give your answer, you give your answer correct to 3 significant figures. All right? If the answer is not exact, and the question did not tell you how accurately you must give your answer, give it correct to 3 significant figures. In case of angles in degrees, you give it to 1 decimal place. All right, that's a standard for one in CSEC. All right, let's continue. Number 3. We want to continue the diagram. So number 3 gives us this diagram. It says the diagram below shows 2 pentagons, P and Q, drawn on a grid made up of squares. So they give us these 2 pentagons right here. And the question says, select the correct word from the list. From this list, select the correct word to complete the statement. Complete the statement right here. So which of these words should go on this line? And everybody said congruent, which is correct. Congruent is just a fancy word for same or equal. Equal in any way. That's what congruent means. Congruent shapes are shapes with the same dimensions, same area, same perimeter. Now notice they are not in terms of rotation. One is rotated, right? One is horizontal, one is vertical, right? But it doesn't matter. They are still the same shape. They are congruent shapes because they have the same dimension, same area, same perimeter, same everything. All right? So they are congruent shapes. So the correct word here is congruent. Congruent is just a fancy word for equal in every way. Congruent. All right? Question said, give a reason why you choose that word congruent. Huh? All sides equal, all angles equal. Basically. All sides equal, all angles equal. So all sides on this shape equal the same corresponding sides on that. All angles in this shape equal the corresponding angles in that. So they are equal in every way. So I'm going to say all sides equal and all angles equal. That's my reason. All sides equal and all angles equal on P and Q. On P and Q, all the sides are equal and all angles are equal. All right? Corresponding sides and angles. All right, that finishes that. 2 marks for that. We want the 2 marks. This question now. That's a polygon question, like a polygon question. Remember, a polygon has n-2 triangles in it. Remember that, right? Every polygon has n-2 triangles in it. It can be broken down into n-2 triangles. Every polygon can be divided into n-2 triangles. And each triangle is 180 degrees. So the total interior angle of any polygon is n-2 times 180 degrees. That's the total interior angle of any polygon of n sides, where n is the number of sides. And this question is going to test your knowledge of this. All right, let's go. Question says, the diagram below not drawn to scale shows a pentagon, VWXYZ. In the pentagon, YZ is parallel to XW. So this and this parallel. So once you hear parallel, you're thinking of Z angles and U angles, co-interior angles. What are the co-interior angles? See here, this and this parallel. Let me use it already. So these 2 sides parallel right now, and they are connected down here with this one. So these two angles down here now are our co-interior angles. Both of them add up to 180 degrees. Good? Co-interior angles, I would call them U angles. All right. Question also said that YZ is parallel to VW. So them two are parallel as well. This and this parallel. And then this is the line connecting both of them. So again, these two angles are your co-interior angles between those parallel sides, this and this. So these two angles again, they add up to 180 degrees. We call them co-interior angles, or we simply call them U angles, but they're like angles in a U. All right? So question also tells us that this angle is 114 right here, and this angle is 98 right there. All right? Question said, determine angle WXY. WXY is this angle. And we said that this angle is co-interior with this one. So them two angles here add up to 180. And then they also state a reason. Let's calculate it, right? So let's calculate it. So we're going to start calculate it. So this is going to be equal to 180 degrees minus 114 degrees. What is your record? How much? 66 degrees. And what do you do when you calculate it? What do you do with it when you calculate it? Put it on the diagram. Good. This is 66 degrees. Put it on the diagram so you can see it. All right? Next part says, the one angle ZVW. Let's mark it. ZVW. 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 This is the angle they want to know. That's the angle that they want. All right? So I'm telling you now, to find that angle, I need to find this angle first. Yes, sir. Then after I find that angle, I'm going to find the total angle. Huh? I'm going to see what the total angle is supposed to be and subtract it from that. All right? So I need to find this angle first, guys. All right? That is the point. So to find, what is this angle? This angle is co-interior with this one, as I said, because this line parallel to this. So these two angles are U angles. So this angle
114 degrees.
114 too. 114 as well. Yeah. So this angle is also 114. Because it's 180 minus the 66 again. So get back to 114. So it's 114 degrees. All right. You could also say that it is the angle between the parallel sides. You know, this side and this side parallel. And these two sides are also parallel. Right? That pair of parallel sides, so the angle between them must be the same. Right? We'll look at it that way as well. So it's 114 degrees, for whatever reason you want to have. And then we're going to look at the total angle in there. What the total angle in there, how many sides are there? It says a pentagon, so it's 5 sides. So let's set up this way. Let's set up this way. We're going to say the total angle, total interior angle, is equal to n minus 2 triangles. N is 5. So it's 5 minus 2 times 180 degrees. Using the formula n minus 2 triangle. The total angle in a polygon is n minus 2 triangles. And each triangle is 180 degrees. That's how we get the total angle in any polygon. N is the number of sides. A polygon can be divided into n minus 2 triangles. Just remember that. N minus 2 triangles. N is the number of sides. So this works out to what? 3 times 180 is how much? 3 times 180 is how much? 540 degrees. So all the angles in here is 540. So to find this one up here, we subtract the sum of these. 114, 66, the 114, and the 98. We get the angle that we want. So we can say, therefore, the angle that we want, which is angle ZVW, becomes 540 degrees minus the sum of everybody else, which is the 98, 114 2 times, 66, and the 114 again. We can write it down here. What is the answer? 148 degrees. Make sure you say it right. So that is the correct process. But I get that? Anyone get 148? All right, beautiful. All right, so let's just remember this formula, guys. Total angle in a polygon is n minus 2 triangles. N minus 2 triangles. Like each triangle is 180 degrees. All right, next question. So this question is a transformation question, clearly. Question says, the letter A and the point C66 are shown on the grid. So this is the A, and this is the point 66. All right? It says, on the diagram, draw accurately. So you must use a ruler and everything, right? Draw accurately each of the following transformations. The first one is an enlargement of letter A of scale factor 2 about the point 66. So if you're using a scale factor of 2, the size of the A is going to be double, but also the distance from the C is also going to be double. And that's a key point for the construction. The 2 scale factor of 2 doubles the distance from the center point of the enlargement. So, for example, this point here, we need to see how far it is from this. That distance is going to be doubled. So we can break it down into horizontal and vertical dimensions. So it's 2 across, 2 down, to go from here to here. So if it is double, it's going to go 4 across, 4 down. All right? 4 across, 4 down. So this point from here, going to go 4 across, 1, 2, 3, 4 across, 4 down, 1, 2, 3, 4. So this point is coming here. That point is going there. That point. But from there, we can literally draw the triangle now. Because this side, this leg, it will be doubled. It is 1 across, 2 down. So when it's double in size, it's going to be 2 across, 4 down. Forget it. But that's what I'm saying. This leg, to go from here to this point down here, it's 1 across, 2 down. We know it's going to be doubled by the scale factor. So we don't want a line that is twice as long. It's going to be 2 across, 4 down. 1, 2, 3, 4. 1, 2, 3, 4 down to here. So that's where it's going. See? 2 across, 4 down. We'll take this point to here. Another thing now. The distance across here. Watch this again now. The distance across here will be doubled to 4. So this is going from this point, you know. So we're going 4 across here to find where this point is going to go. So 1, 2, 3, 4. It's going to come here. So this point is going to come here. We'll finish. We can check all of that, you know. So our A is coming there. Our A is coming right here. So we can draw it like this. Draw it like that. That's the main part of it, right? And if we were to test with the construction lines through A, through the center point, it is like this. This go to that. This one come through this point and go down to that. This one come through this point and go down to that. That's how the enlargement works. The distance from the center is doubled. We don't put the middle line yet. We don't put in this middle line yet. This line across here. This line in the middle here. So this line. Let's zoom it up. This line. I want to put it precisely, right? So it's not exactly, notice, you know, if you look at it, you know, it's not exactly 1 below this, you know. Right? It's a little less than 1 below, don't it? So basically, it looks like it looks as if it wants to be this line, don't it?
Yes, sir.
Don't it? But based on this diagram, it's not exactly on this line. You see that? So basically, what we can say is that the distance between this line and it will also double, don't it? So then it's like a space right there, so you have to double it as well, because the scale factor is 2. So if I double that little space there, it looks like it comes to about here, so. It don't quite reach this line either, you know. Right? The question says draw it accurately, you know, so everything important. Mathematics is the most exact science. So I'm not gonna put it on that line. So don't draw it to the frame like me. You have to draw it to the ruler, guys. But basically that's what you're supposed to get. Something looking like that. Let me take this off. That's what you're supposed to get. Get that to get your marks. Get that, you get your marks. Very good? All right, good. All right, moving right along. Next part wants us to do a translation of the A -3, 2. So remember that -3 is the horizontal movement. Second value is a vertical movement, right? So this -3 means we're gonna move 3 to the left, 3 to the left, and the 2 here means that we're gonna move 2 up. So moving the A, 3 to the left and 2 up. 3 to the left and 2 up. We just need to move 1 point and we'll just draw by the A with the same dimensions from that 1 point, right? So let's say we're moving this point here. This point, let's zoom up on it. All right, 2 to the left. And these are all 1 unit. 1 centimeter is 1 unit. So it's 2 to the left, no, 2 to the left, 3 to the left, and 2 up. So this point is coming 1, 2, 3, 2 up. 1, 2. So this point is coming right here. So now that we know that the point is right here, we can draw by the same shape around it. All right, so this leg is 1 across, 2 down to get it. So this leg would come here. The base of this leg right here will be here. And then the base of this leg will be 2 across from this right here. And so this will be the A, the main portion of the A. And then the line inside here again, we'll draw the same way again, a little bit above this halfway line. So we're going to come and draw it a little bit above here. And that is the shape right here. That's the translated. Very good. That's what you're supposed to get. And it have to be exact. Somebody have a question? Somebody online have a question? All right. Nobody have a question. But that is it, guys. Anything else? That finishes that question. 9 marks. Nice and easy. 9 marks. Next question. Let's move on. This is our functions now. All right. So this question says the function f is defined as this: 3 minus 2x. Another way of writing this is simply to say f of x equals 3 minus 2x. The same thing. This and this is the same thing. All right. It says determine. It said the diagram below shows the mapping diagram of the function. Determine the value of a. So basically, it is -1 mapping onto a. So basically, we're going to plug the -1 in here to get the a value down here. That's what it is now. Plug the -1 in the function to get the a value. Or we can put it another way. We can say the a really is equal to f of -1. See that? A is the resulting value when the x is -1. So you plug the -1 in the function here. Same thing. So it's going to be 3 minus 2 times -1. It's minus is a plus. And so it is 5. A equals 5. So the A equals 5. A equals 5. All right, as a linear relationship, so if you have the 5 here, you see that you're reducing the values by 2 each time. See that? See that? You're reducing the values by 2 because a linear relationship. All right, so that is it basically. A equals 5. 1 mark, 1 to 1 mark. Down here now, it says determine in the simplest form the inverse of f, which is f to the -1. Remember, the f, let's write by the f. The f is equal to 3, f of x, or the f is equal to 3 minus 2x. Now, some teachers call this x and y, interchange the x and the y, right? No problem. We do it that way, I get the right answer both. But our method is to interchange the f and the x. And so our inverse function, this will become x equals 3 minus 2 times f to the -1. So the x becomes the f to the -1, and then we're trying to make the f to the -1 a subject. All right, so we can carry this -2 f to the -1 over this side, make it positive, and then carry this x over this side and make it negative. So we're going to get 2f to the minus 1 equals 3 minus x. And all I have to do now is divide through by the 2. Divide through by 2. So we're going to get f to the minus 1 equals, can divide each term by 2 and get 3 over 2 minus x over 2. And we can put in by the of x right here. Let's use a different color to put it back. And in the case, this is the answer right here. Whichever way you want to do. So you want to use the x and y method and do it, no problem. That is supposed to be the answer. If you got 3 minus x all over 2, that is still correct. 3 minus x all over 2 is still correct. If you got this, right? If you got 3 minus x all over 2, that is still correct. All right. Next part says you must do the composite function f squared. Remember, f squared does not mean that you're squaring the function. F squared actually means f of x. So you're basically putting f into itself. You're putting f into itself. Understand? Yes? You got x take away what? If you get x take away 3 over negative 2, that is still correct. That is still correct. All right? If you get x minus 3 over negative 2, still correct. Cool? So all these answers over here, basically is the same thing. All the same thing. So if you get that, is still correct. Already know. Back to the f of f. So let's construct the f of f right here and show you. So like we have the f, and it is 3 minus 2x. Or also have f again, and it is 3 minus 2x. I want to put f into f. So like we take all of this f, or bring it and put it into this, where the x is in this f over here. That's what this does. F into itself. So you take all of the f and you put it into the other f where the x is. All right? That's how you do the square. And so this thing becomes f squared of x, which is f of x. Basically making this construct, it becomes 3 minus 2 times, and then putting back all of f there, which is 3 minus 2x. Good? I can simplify this down. It's 3, careful, is negative. The negative 2 times 3 is negative 6. The negative 2 times negative 2 becomes positive 4x. So it becomes negative 3 plus 4x. Or if you like, you can write 4x minus 3. That is the answer. 4x minus 3 or negative 3 plus 4x. All right, that is it. Next part. State the value of this. Answer for this is just negative 2, you know. So what does that mean here? It's like you do the inverse of negative 2. And then you reverse it with the f. You reverse it with the f. So remember, f to the minus 1 and f are inverses of each other. Right? So it's like you do, it's like you have the negative 2, right? Like you have the negative 2. And you apply f to the minus 1 to it. F to the minus 1, you apply it to it, right? It's going to take it to some value here. But you don't know the value. Let's say we take it to some value here. The f on this now, because you remember you're applying the f to that result now. So the f on this is going to reverse it back to this. If you apply the f, it's going to take you right back to the 2. You understand that? You understand that? Do you understand that f and f to the minus 1 are reversal of each other? Like you're driving a car. Think of you in a car. And you reverse it. You reverse the car between 2 points. And then you drive it back forward. So it's like the f to the minus 1 reverse the car. And then the f drive it back forward. You're going to end up where you started. So if you started at negative 2, so the negative 2 is at the gate. Right? And you reverse from the gate to a wall. And then the f now is going to drive you back from the wall back to the gate. So the result, you end up where you started. Understand that? That's a simple way to put it. So whatever the f to the minus 1 did, the f inverses it, the f reverses it. Whatever the f did, f to the minus 1 reverses it. So if you composite those two things, they net out to nothing. You understand? So that you apply a function and you reverse it. So you come back to where you started. So if you started at -2, you're going to end up back at -2. I don't even want to waste time to do the calculation with this. But the answer is just going to be -2. You must understand that concept. Question says state. That's why them say state. No calculation are needed. Question said state. No calculation needed. You will need to understand that f and f to the -1, they are inverses of each other. They reverse what? Anything where f do, f to the -1 reverses it. Anything where f to the -1 do, f reverses it. And what is a composite function? It's a composite function. But remember also, you know, that this composite function, it means f to the -1. I do the f to the -1 first, followed by f. That's what a composite function is, you know. If it was f of g means g followed by f. In other words, you were doing g first and then doing f after. So this composite function means do f to the -1 first and then do f. F to the -1 is the inverse of f, and f is the inverse of f to the -1. They are inverses of each other. You understand that? So anything where f to the -1 did, f will reverse it. Anything that f did, f to the -1 will reverse it. So if you composite them net out each other. So that the f to the -1 move to a value, the f move it back to where it was. So the answer is just -2. I'm not going to do any calculation for something like this because it is simple. And the CSEC knows it's simple. That's why them say state, and that's why they give all the 1 mark. Can no work needed for it. All right? I'm going to leave this on the screen. I'm going to leave this. Let me leave those 2 things on the screen. These 2 things. Let me leave them here. All right? So understand that this composite function means you do f to the -1 first, you do this one first, and then you do this second. And they inverse each other. They reverse what each one does. All right? So if you start at f to the if you start at -2, I apply f to the -1 to it, the f is going to carry you right back to the -2. That's going to reverse the process. But I go to that. All right, beautiful. Nobody waste time on work this one. The answer is just -2. All right, good. Next question. This question said, they want us to draw these lines. It's like a linear programming inequalities. It's a use a ruler, draw the line x equals half. X equals half is a vertical line passing through half, right? Remember that. The y-axis is x equals 0. So x equal a number with the vertical like the y-axis. Just as it passes through half on the x-axis. All right, plenty of people want to draw the line horizontally. It is rough. X equal a number is vertical. Y equals a number is horizontal. What you can remember is to remember that the x-axis is y equals 0. So y equals a number, like for example, y equals 2 will be this line, a horizontal line passing through 2, y equals 2. All right, so let's do that. So the vertical line x equals a half. So look at the grid. Based on this scale right here, this is where a half would be, right here. Right here is a half. So the x equals a half will be the vertical line up here. Let's supposed to use a ruler. I don't have any ruler. I'm going to draw it with my free hand. This line is x equals half. This line right here. Draw it with your ruler, guys. Don't do it like me. Draw it with your ruler. And you label it. X equals half. That vertical line. X equals half. Then I want this line. Y equals x. Easy line. Y equals x is the line that passes through points where the coordinates are the same. Now I see people online doing question like this, and the question says draw a line y equals x, and then just draw one random line up so. No, mathematics is the most exact set, especially on a graph. It has to be precise and accurate. So you have to draw the line through the correct points. So y equals x, as it says, it passes through points where the x and the y value is the same. So it passes through 0, 0, it passes through 1, 1, it passes through 2, 2, it passes through 3, 3, it passes through 4, 4, and so on. If the y scale and the x scale is the same, it will pass right down the middle of your graph and be at 45 degrees to the x-axis and to the y-axis. All right? So we want the line right down here. This line we want, this line, right through those points. And generally speaking, you try to go right through the graph. Right through the grid, I should say. Right through the grid. Use your ruler and do it. Don't draw it with your free hand like me. I don't have any ruler. So I'm drawing it with my free hand. Use your ruler and do it. And label the line. Y equals x. Then we have the x plus y equals 5. It's an easy line to draw. I call it the x plus y line. The x plus y line is a popular line. It means that it crosses the y-axis and the x-axis at that value, 5. So the x plus y equals 5, crosses the y-axis at 5, and crosses the x-axis at 5. If it was x plus y equals 10, it will cross the x-axis at 10 and cross the y-axis at 10. If it was x plus y equals 50, it will cross the y-axis at 50 and cross x-axis at 50. Note, I said x plus y. Not x minus y, not 2x plus y, not x plus 3y, x plus y. But understand that. Let's look at why that is so. X plus y equals 5. X plus y equals 5. You see, on the x-axis, the y value is 0. So the x must equal 5. On the y-axis, the x equals 0. So the y must equal 5. Let me say it again. On the y-axis, the x equals 0. On the y-axis, the x equals 0, so the y equals 5. And on the y-axis, the x equals 0. On the x-axis, the y equals 0. On the x-axis, y equals 0, so the x equals 5. In any case, it passes through 5 on the y-axis and 5 on the x-axis. It's an easy line to draw. So let's see to mark that way the pass. It passes through 5 up here, so, and 5 down here, so. That's all. But understand that. And the pass through points where the sum of x and y is the same. So for example, I pass through 1, 4 here, so, and 2, 3 right here, so, and 2.5, 2.5 right there, so, and 3, 2 right there, so, and 4, 1 right here, so. So you pass through all those points. But you never need them intermediate points here. You just need this one and this one. Line it up with the ruler and draw it. Get me? All right, so let's go. So let's draw that with the ruler now. Use the ruler and draw it. Don't draw it freehand like me, guys. So this is the line that we want. Use the ruler and draw it precisely like that. Label it. X plus y equals 5. That is that line. X plus y line. So that is how your graph is supposed to look. You must use straight lines on it, not freehand like me. It must be nice and neat. Then the question says no. On the grid, label as R the region where x is greater than or equal to 5, y is greater than or equal to x, and x plus y is less than or equal to 5. Let's analyze it. X greater than or equal to half means that we want the region to the right of the line x equals half. Greater than half. So x equals half here, that is this line. We want where x is greater than half means that we want to the right of this line. So the equal in the inequality means that we also want the line. So the line is solid as it is there already. And the greater than means that we want values now that are greater than half. So we're going to the right of this vertical line, the right of it. Let me put down in blue. We're going to the right of this line to satisfy this inequality. Not going to mark anything here. We're going to put it what it is first. Then this one now. This means that we want to go above the line y equals 2 because of the greater than here, and the y on the left side of the inequality is positive. The greater than means above, And the equal means the line as well. So the equal in the inequality means the line as well. So the line is drawn solid. And then the greater than means above. So we want to go above the line y equals x. So line y equals x here. We want to go above that line. Above this line. So we're going to the right of this one and we're going above this one. Look like it is in here, so what? Then this inequality now. This one. Look at it now. Y on the left side of the inequality is positive, and so the less than sign means below. Below, we want to go below this line now. We want the region below this line, and the line is the x plus y equals 5. The less than means we want below the line. The equal on the inequality means that we also want the line, so the line is drawn solid. It is already drawn solid, but we want to go below the line. So we want the region that is below this line. So this inside there is a region that satisfies all three. That's where the R is. That's the region that we want. We want the region that is above this horizontal line, to the right of it, because x must be greater than half. We want the line that is above this one, because the question did say greater, y greater than x. So we want above the y equal x line, which is up here. We want the region below the third line, below this line. So the region that satisfies all those three is what we wrote inside here. It's R. So we put the R in there. Everybody good? Online, everybody good?
Yes, sir.
All right, good. That is it. I'm just trying to explain as much as I can. All right? I will revise it. Next question. Statistics. And this is an on-group statistics. The hard to give on-group statistics question. Most time the statistics is grouped. You have to draw a cumulative frequency graph on histogram. You have to estimate everything. When the group data is grouped, you're estimating everything. When the data is on group like this, you know the actual values. And so everything you can calculate exactly. Exact values you can calculate. Mean, median, mode, and all these things. Range, interquartile. You can calculate the actual values. But the data is known because it is on group. When the data is grouped, you generally don't know the actual values and you have to estimate the mean, estimate the median, estimate all these things, right? All right, so this question says 60 students. I'm going to put 60 right here. I don't want to forget. 60. So everybody here is almost up to 6. I'm write it down here as well. I don't want to forget that it's 60 students. 60 students took an algebra test, which comprised of 15 multiple choice questions. It says the number of correct answers that each student obtained is recorded in the table below. So these are the scores that they got. So nobody got less than 8. And nobody got more than 15. Oh, well, it actually was 50. So some persons got 50. So basically 6 students got 8. 14 students got 9. See? 2 students got 10. And if you notice, data is in ascending order from the ones up here who got a lower number of marks to the ones up here who got the higher number of correct answers, right? So the data is in ascending order. Ones who get the low marks are up here. Ones who get the higher marks are up here. So the data is in ascending order this way. Just like it is in a table. So because it is in ascending order, we can, for example, calculate median. Remember, the data has to be in ascending order. We're going to calculate median and interquartile range and so on. Right? So that's what I want. The question says, we are to determine the number of students who had exactly 13 correct answers. So 13 correct answers here. These are the number of students, 11. So that 13 correct answers was gotten or was achieved by 11 students. So 11 students. So this is 11. 11 students got 11, got 13 questions. 11 students got 13 correct, exact. That's it. So you see, this is exact data. I will know the exact values from this. So this is everything we're calculating can be exact. We don't have to estimate, right? Next question. The modal number of correct answers. The modal number of correct answers, the number of correct answers that occurred most frequently. What the answer, the number of correct answer that most persons got. Highest frequency right here is 14, not it? So 9 is the number of correct answer that most people got. So that 9 is a modal number of correct answer. Remember, don't put the frequency. These are the frequency values. These are the score values. Remember, the mode is a score. It is not a frequency. Some persons will put 14 as the answer. The mode is one of the scores. Mean is a score. Median is a score. Interquartile range, semi-interquartile range are score values, not frequency values. What understand that? So if the question asks for a mode, you cannot give a frequency as the answer. You have to give a score as the answer. The marks for a median, same thing, it's a score. So it is a score that is your mode, not the frequency. You're looking for the highest frequency. The score that corresponds to the highest frequency is 9. So the answer right here is 9. 9 correct answers, 9. Bam. 9 correct answers. Everybody go to that? Yes. All right, let's continue. Next thing I want is for us to tell them the median number of correct answers, the median. Now, because the data is exact, I will know the data. We don't have to estimate it, we can actually calculate it. Now, think of how you calculate median. Remember now, median is the value in the middle of an ascending set of data. There are 60 pieces of data right here, an even number of data. So basically then, if you divide the data half and half, the number of scores half and half, you're going to have 30 and then 30, don't it? So the median is going to go right in between the first 30 and the second 30, don't it? The value in between the first 30 and the second 30 is the average of the 30th value and the 31st value. Can you appreciate that? So let me set it out for you so you can understand it. I want to find the median. So let me have the first 30 values here, so 30 values, the first 30 values. From value number 1 to value number 30. So let me say the first value and the 30th value. That's the first set of values. I'm dividing the 60 values half and half, the 60 score that the students got. Then you start from the 31st value up to the 60th value. So you have the bottom half, and you have the top half, 30 and 30. And you want to find the median. Since there's an even number of values, you have to calculate the median and put it in between them, right there. Don't it? Because when you have the median, you must have the same number of values less than the median as they are above the median, don't it? So if it's 60 values, they're going to divide it 30-30. And you're looking for the value, the average of the two middle values. So the two middle values is going to be the 30th value and the 31st value, don't it? So the question is, how do we find the 30th value and the 31st value? Huh? When the frequency reaches 30. So we're looking for the 30th value and the 31st value in the frequency. See there now? So you have to add up these values down here. You're counting them until you reach 30 and 31. And then you can match the score over here. What is the 30th value? What is the 31st value? So that's the purpose of a cumulative frequency column, you know. Cumulative frequency. That's what the cumulative frequency do, you know. It's like it's counting how many values you have as you go down. That's what it is doing. It's adding up your values for you. So first you have the first 6 persons, which is 6. And then you have 14 more persons. So by the time you finish this set, with the 9 persons who get 9, you know, have a total of 20 persons. And then you have 2 persons who got 10. So you finish those 2 persons who got 10, you know, have 22 persons in all. See that? And then now you come, so you have all the persons who got 11, 6 of them. So you now have 6 more persons, you have 28 persons. See that? And then now you have the 2 persons who got 12. So you now have 30 persons in all. So when you reach here, so you have 30 persons. So the 30th person got 12. And the 31st person start right here, so at 30. So here, so now when you finish this group, you're gonna reach 41. So the 30th person is the last person who got 12, and the 31st person is the first person who got 30. But understand that? You understand that? But understand that? So the 30th person, this is the 30th mark, and this is the 31st mark. So the median is the average of these two values. You understand that? The median is the average of those two values. The 30th mark in the ascending order is at 12. And the 31st mark is at 13. The median is the average of those two. 12 plus 30 over 2, which is 12.5. So the median is 12 plus 13. I'm going to call the median Q2, second quartile, over 2, which is 12.5 correct answers. But understand that?
Yes,
But
sir.
understand that? All right. So those who didn't get it right, learn from your mistakes. I tell you, when CSEC gives on-group data, a lot of people don't get it right, Why? Because we don't get a chance to practice it a lot. Because most of the CSEC questions in statistics is group data. We have to get it from a cumulative frequency curve, and nobody doesn't say half of the data to find the median, right? But this time you have to count up the people, count it up. I understand that. So they'll do the same thing almost as same thing that you would do if the data was raw data. Basically, you're doing the same thing. 60 persons, you want the 30 and the 30. So you want to go right in between the first 30 and the second 30. So you end at the 30th person and start back at the 31st person. So you want the 30th mark and the 31st mark and you average them. Happens to be 12 and 30. So the average of 12 and 13 is 12 and a half. If you have what? Mathematics is the most exact science. And I said to you, when the data is on group, everything is exact. So you cannot put 12. Because 12.5 is the correct answer. Learn from your mistakes. Better go to that. All right, learn from your mistakes. So the correct answer is 12.5 marks, or 12.5 correct answers. 12.5. All right? All right. Next question says, the probability that a student chose at random had at least 12 correct answers. Now, at least 12 means 12 or more, don't it? It means greater than or equal to 12. You want them to have greater than or equal to 12. 12 or more, don't it? At least 12 means 12 or more. So we need to count on them how many persons got 12 or more and divide that by the 60 persons. That's all? So let's go. So let's look at it. So these are the 12 or more marks persons. See them here? These are the 12 or more marks. These persons right here. How many of that? 32 persons that? 32 that? Not sure? Don't remember. All right, so this one, yes, 32. So this one is at 20, this at 30, and 32. Right, so this add up to 32. 32 persons out of the 60. So the probability, that like a 52, man, 32. All right, so the probability is 32. So it's 32 out of 60. And I simplify it down to the lowest term. What does that work out to? Simplify the lowest term. 8 over 50. That's the probability. Better go to that. Online, nobody okay?
Yes, sir.
Gentlemen, you good?
Yes, sir.
All right. Pay attention, man. No mock exam. Huh? What mock exam you do? What mock exam you run out? About 30. Everybody has about 30 mock exam you do 3. Huh? Where I get 1? All right, make sure you know. I'm going to mount it down, you know. I'm going to look for you personally. Grade 1 straight A's. All right, next question. Let's go. Next question. Ready. Let's see who got this question right. I like this question a lot. All right. So listen now, listen now, listen now. Remember, ratio is just breaking down a total actual value in the simplest to the simplest value. So therefore, you can build that ratio that they give you back up to your actual values. And that's the way I like to approach ratio questions. Take the ratio that they give you and try to attain what the actual values are in the same ratio. So ratio questions can be done by simply multiplying and dividing by values to get back to your actuals. And then once you have the actuals, you can deduce anything. Remember, when the question gives you a ratio, you can put in other aspects to that ratio. So for example, you can put in the difference of values. You can add in a section to the ratio that is the total. You can add in a section to your value that is the difference between two values. Anything that you want to know. But understand that. So let's go. This question says, a group of students wrote a physics exam. Each of the students achieved a grade 1, 2, 3, or 4. We none of them grade on yourself. None of them grade on yourself. We work with the 1 and the 2. Only the 3 and the 4 business. All right, let's go. Question says, the pie chart below shows the results. And the only value they give us down here is this one. All right, so grade 3, 39 persons got grade 3, and 39 out of 39 persons got grade 3, represented by 117 degrees out of 360 degrees, which represents the total. Multiple ways to do it. Multiple ways to do it. We know that the 170 degrees is out of 360. It is the same ratio with the 39 students to the total, right? Question says, 39 students achieved a grade 3, as we can see. Determine the total number of students who wrote the exam. So I would say total number of students who wrote the exam corresponds to 360 degrees, don't it? So we can use it as a ratio relationship almost. So we can say something like this. We can say something like this. 117 degrees is equivalent to 39 students, don't it? We want to know what 360 degrees equivalent is. So what we can do, we can find what we need to multiply this by to reach 360 and multiply this by the same thing. Or we can bring this down to 1 first and then multiply it by 360 to see what 360 is equivalent to. Anything with 360 degrees is equivalent to is the total number of students. But understand that. So I will bring it down to 1 first, divided by the 117, and divided by 117 as well. And then carry it back to 360 by multiplying by 360. Multiply by 360 and multiply by 360 as well. See that? So when I get this side equal 360 degrees now, this side is now 360 degrees. Is equivalent to, work this out now, that's the total number of students. Write that out for me now. 120? Yes, sir. Let me make sure. Not just on here now. Just enough. 39 times 360 divided by 117. 120 students. So that's the total number of students in the survey. 120. No, I'm not saying that you have to do it this way, guys. You don't have to do it this way. Anyway, you do it and get 120 good. That's not the only way to do it. You get 120 same way? Good. So you don't have to tell me anything. You have to tell me anything. I can do it 5 more different ways and get the 120. All right? Very good. But I want us to understand that 360 degrees represents the total, right? Right? We could have set up like this as well. What to go for this as well? We have set up how we would normally find the angle. Look how we would normally find the angle. To find the angle of 117 degrees, let's do it another way. How we normally find the angle in a pie chart. We normally say the 39 students over the total number of students multiplied by the 360 degrees equal to 117 degrees that they got, don't it? And we're solved to find the t under there. See it? Could I do it that way too, you know? We can do it many other ways, but let's just continue. That's it. And the 120. So watch me now. Let's pull out the data. If this is 39 students and the total is 120, what them three add up to? We need to know what them three add up to. Huh? No, not the degrees, the number of students. 81. So these three up here add up to 81 students. So 81 students got grade 2, 1, and 4, right? 81 students. So that information might become relevant. All right? So these three around here, add up to 81 students. All right. Let's continue. Question now says, ratio of the number of students who achieve 1, 2, and 4. Same student we just talk about, you know. The students who got grade 1, 2, and 4 is in the ratio 2 to 4 to 3. It's them same students over here, so we are talking about, you know, 1, 2, and 4, you know. We know that the total of them must be 81. So look how we're going to do the maths now. Watch it now. Go ahead and do the maths now. Go ahead and do the maths now. Watch this now. Them say, how many students pass the test? People who pass it get 1, 2, and 3, but I want to know the actual number of students for everybody. If I know that, I can answer any question, right? Watch this now. So 1 to 2 to 4 to grade 4 is in the ratio 2 to 4 to 3. I'm going to add in a section to the ratio. I'm going to put in a total right here, so total of these. Because I know that that total of these is 81. That's information that I know. I know so the total person who get 1, 2, and 4 is 31 enough. So I'm going to put in a total here. So this add up to how much? This add up to 9. See that? So this is my broken down in the lowest values of my actual number of students. My actual number of students who got these grades is 81. So if I want this ratio to show my actual number of students, I need this to become 81, don't it? What do I multiply by? 9. So if I multiply the ratio by 9, it will show me my actual number of students, don't it? So when over here becomes 81, which is my actual, this becomes 27, this becomes 36, and this becomes 18. So those are my actual number of students now, you know. And what I also know? I also know that the person who got grade 3 was 39 students, don't it? I also know that 39 students got grade 3 over here, so don't it? You know that, you know, 39 students got grade 3. So more of the students who passed, don't it? So the students who passed are those who got grade 1, plus those who got grade 2, plus those who got grade 3, which is equal to 18 plus 36 plus 39. 18 and 36 get 1 and 2, and 39 got grade 3. What is that up to? So what do we got to for me? 93? 93 students is the answer. And anything them ask me now, I can answer. Because I know the actual number of students, right? I know everything now. And that's how I like to approach these questions. Work to find the actuals. You know the actuals? Remember the ratio that they give you is just the lowest form of what your actuals are. And you can multiply back up to your actuals. Once you know your actuals, you can calculate anything after that. Determine the value of the angle in the sector representing the grade 1 in the pie chart. Grade 1. How many persons got grade 1? 18, don't it? Yes. So it's 18 over the 120 students times the 360 degrees in the pie chart. That's the angle represented by the grade 1 student, don't it? 18 out of the 120. So important as finding the actuals. That's important as finding the actuals. Just remember, ratio is just a broken down format of your actuals. What is your go to? 54 degrees? All right, I trust you. 54 degrees. All right, that is it. I like this question a lot. I like it a lot. Everybody good? Everybody okay? Write this better. Grade 3. Grade 3. 39 students. 39 students graduation. All right, so we know what actuals we're using. All right, question done. 9 marks for that. Next question. But the online okay?
Yes, sir.
Sir.
All right, good. Next question. Remember, ratio is just a broken down format of your actual. So you can use your ratio, build back up to your actual values. And once you know your actual values, you can answer anything. All right? This question now. This question says, you must take pi as 22/7. So once you see that, you know that more than likely some circle thing coming into play, right?
Yes, sir.
Pi is 22/7. Diagram below shows a rectangular tank with the base 54 centimeters by 40 centimeters, 54 by 40. That is used to store water. The tank is filled with water to a depth of 15 centimeters. So it has a depth of 15 centimeters. Calculate the volume of water in the tank. That's the length times width times height, right? Cross-sectional area times the height, right? So the volume of water in the tank will be equal to 40 times 50 times 15, not it? Easy stuff. What is work out to? And the CM cube, what is work out to? Give me digits, give me digits. 3, 1, 2, 3, 4, that's it? Centimeters cube. All right, that's it. Length times width times height of the water. Good, so that's the volume of water in the tank, right? Question now says, a cylindrical container shown in the diagram below is used to fetch water, to fetch more water to fill the rectangular tank. Oh, see, so I'm going to take this and I'm going to pour it into the rectangular tank, right? It says the container, which is completely filled with water, has a radius of 20 centimeters, as we can see here, and a height of 21. It's a cylindrical tank. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So we're going to need to calculate the volume of that and add it to the volume that was in the tank, right? So let's calculate this as volume in the cylinder. Can we do it right up here? Can we do it under here? So the volume of a cylinder, remember, is pi r squared h, right? Area of the base times the height. All right? So let's do it this way. Volume added. Let's do it this way. The volume added is this, pi r squared h. The pi is 22/7. That's what they said. The radius is 20. So this is 20 squared times the height is 21. What is work out to? 26,400 cm cube. So the volume now, volume in the tank, total volume. Is therefore the 30,000 that was there before, plus the 26,400, right? That looks like 56,400 cm cube. That's the new volume in the tank, right? Very good. New volume in the tank. Next question says, 3 marks for that. Show that the new depth of water in the tank is 28.2. The new depth of water in the tank is 28.2. So let's look at what is happening up here. So when we add water to the tank, the volume is going to lift up to some new level like here, right? It's going to lift up to there. It's going to have a new height, which we're going to call H. We don't know what it is. So the area of the base times this new height is now going to be equal to the new volume. Nobody understand that? So it's going to be 40 times 50 times H. It's going to be equal to the new volume. And the H is supposed to come out to what they said, right? Another way we could do it, you know, we could use the 28.2 with the 40 and the 50 and get the 56 something that they said. That's another way we could do it, right? Well, let's do it by finding the H. All right, so let's look down here. So calling the new depth H. I'm gonna call the new depth H. All right, the new depth is H. So the volume in the tank The volume in the tank is going to be 56. The volume in the tank is 56,400. The volume in the tank is 56,400. And the volume in the tank is actually 40 times 50 times H. That equals the 56,400. So to find the H, we divide by these, right? So the H then will be 56,400 divided by the 40 and the 50. And it's going to work out to 28.2 centimeters. Shown. That's what they're going to get, 28.2. So the new height is 28.2. And it's coming from what? It's coming from 50, don't it? Coming from 50. Notice now. The vertical height of the tank is actually 48. The vertical height of the tank, rectangular tank, is 48. Determine how many more cylindrical containers of water must be poured into the tank to completely fill it, to be completely filled. So how many more containers of water? We can do it two ways, you know. We can work out what the volume is when it's full. I have to see how much more required to fill it, but I think the easy way to do it is to actually work with the height. Because we know the height where the one container raises it to. One cylinder raises it to. I want to see what the remaining height is. Let's look at it this way. So it was the one cylinder, one refill. Let's put it this way, one refill. One refill is equivalent to what change in height? It's equivalent to 28.2 minus 50. What is work out to? 13.2 centimeters, don't it?
Yes, sir.
So every time you refill it, it increased by 13.2 centimeters, right? So how much we need to fill the tank now? It is at 28, don't it? And we can it up to 52, 48, don't it? So what is now? Required to full. Required to full in terms of height is 58 minus where it is now, the 28.2. 28.2. That is the amount that we require to pull it. The height we need to cover. What does it work out to? How much? This work out to 13.2. 58, 30.2. 58 minus 30. Huh? So tell me now 58. Oh, it's 48. Sorry, it's 48. My mistake. Not 58. 48. My mistake. 48. Yeah, it's 48. Where is it all from now? 48 minus 28 point. What is it? 19.8 centimeters. You need to pull it. All right, 19.8 centimeters, right? And every time you pour one in it, this is the amount that you cover, don't you? So all we need to do is see how many of this can fit into that. See that? So the number of refills is going to be equal to the total height you want to cover divided by the amount that they cover each time. What is work out to? 19.8 divided by 13.2 is what? Huh? 1.5? 1.5. So you need 1.5 more container full. I.e., that is 1.5 containers. See? How many more containers? 1.5. 1.5 containers in here. 1.5 containers. But that's not the reason behind this question. We look how much it increased by each time you pull it. You put a container in it. Each time you put a container in it, it raised by 13.2. How we know that? Because originally it was at 15. It was at 15 when we started, right here. And when we put the first container in it, it go up to 28.2. So it means that it raised by 13.2. So each container will raise the height by 13.2. 13.2. And then now, if it is at 28.2, I want to carry it up to 28, then the required height to fill is 19.8. So we need to see how many times we can put 13.2 in 19.8. and it's 1.5 times. So 1.5 containers will fill the tank. But understand that? You could also do it by calculating the actual volume, but I think this is the easy way to do it. I think this is the easy way to do it. Everybody good? Online, everybody good?
Yes, sir.
All
Yes,
right.
sir.
All right, good. Next question, number 7, pattern question. The diagram below shows a sequence of figures made up of circles with dots. Each figure has 1 dot in the center and 4 dots on the circumference of each circle. The radius of the first circle is 1 unit. That is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Except for the first figure, a portion of each of the other figures is shaded. All right, so I give all that information, right? So this is just describing what is happening here. Most of it irrelevant, really. This is figure 1, figure 2, figure 3, figure 4, and so on. It says complete the rows in the table below for figure 5 and figure N. So what we want to do is look at the pattern of the numbers to complete it. All right? Now, normally we can actually fill this out without the use of the diagram. But the numbers are in a pattern, just for us to see what the patterns are. And I like to do my N first. Because when you do your N, then you can use the formula to get the rest of the information, right? All right. Now, the beauty about this question is that they give you a 5, which basically comes right after the 4. So you can essentially fill out this line by catching the pattern and adding what the next value is supposed to be. Some other times you have to actually calculate, because they don't necessarily give you the one that comes immediately after, right? All right, let's look at these values first. They are all increasing by 4. Plus 4, plus 4, plus 4. See that? All increasing by 4. So the next value is going to add 4 to this, don't it? Plus 4. So that's 21. So the next value right here is 21. Let's put in the formula here now. Because these are increasing by 4, 4n is a part of the formula. But the first value is 5. So we need to add 1 to get the first value. Get the first figure, because in the first value, n will be 1. 4 times 1 is 4 plus 5. So the formula is 4n plus 1. But understand that?
Yes, sir.
Online, understand that?
Yes, sir.
All right.
Yes.
Then this one now, as you look at these are all squared numbers. See that? They are the perfect square of these, and they multiply them by pi. See that? And so this is 5 squared. So this therefore is going to be n squared times pi. N squared times pi. Easy. Look at these now. These are all increasing by 2. No, sir. These are all increasing by 2. Keep adding 2. All right? So because you keep adding 2, you're going to add 2 again to this one, and you're going to get 9 pi. 9 pi. Because these are increasing by 2, 2n is a part of the formula. 2n pi, 2n times pi. But this is only 1 pi. So we're going to have to subtract 1, and then we're going to multiply by the pi. So it's 2n minus 1 times the pi. That's what it becomes. Let me make it a little smaller. So that's what it becomes. 2n minus 1 times the pi. Yes?
If you don't put the pi next to it, it will still be right.
Nope. Gonna be wrong, because all of these are 5. So you have to put the pi beside it, son. Okay?
Sir, I'm putting
Yeah,
just like us.
Yeah, I'm answering. And that's what we learn. That's why I make the mistakes and learn from it. So you have to maintain whatever is in there. So you have to put the pi beside it. You have to put the pi beside it. Over here now, what we find happening over here is that this increased by 4, and then this increase by 6, and then increase by 8. So basically increasing the increase by 2 more each time, right? So that doubling is like you keep increasing what you did before by 2, right? Now, because of my experience, I know that the formula for that is going to be n times n plus 1. N times n plus 1. and then put the pi on it, right? So whenever you're doing a question where the values that you're adding increases by 2 is n times n plus 1. And you can know as well, look here. This value over here is a product of 2 and the value that comes after 2, which is 3. See that? 2 times 3. Yeah, put n squared plus n. N squared plus n. That n squared plus 1. If you expand this, it will be n squared plus n, 5. If you notice, this value 12 is 3 times 1 value after the 3 is 4. See that? 3 times 4. This one is 4 times 5. 4 times 5 is 20. So it's 4 times 1 more than 4. So it's n times n plus 1. Now let me tell you something. There's another pattern if the values were increasing by 1 more than the time before. In other words, if it was a pattern like this, 1, then 2. So you add 1 to this, right? Add 1. Then you add 2 to get 4. So you add in 2. And then you add in 3 and get 7, add 3. If you get a pattern like that, check if this will work. Half of n times n plus 1. Check that if that will work. So if you get a pattern where the values that you're adding is increasing by 1 more each time, then check if this will work. Half of n times n plus 1. Cool? Check if that will work. Half of n times n plus 1. If the values are increasing by 1 more. These are increasing by 2 each time. The amount that you're adding is increasing by 2 each time. So the pattern formula is n times n plus 1. But if increasing by 1 more each time, then try this formula. Half n plus 1. All right? And test if it will work. Try it and test if it will work. But that is it, guys. That is the table complete. Next question. It said determine the value of n when the number of that is 541. Stop talking, I'll go outside. Number of that is 541. So basically put in this formula equals 541. See that? So that's, remember, this is the formula for the number of that. So it's 4n plus 1 equals 541. 4n plus 1 equals 541. So 4n equals 540. They divide by the 4, right? 540 over 4 is how much? N equals 135. So that is it. N equals 135. All right, good. Next part says, write down in terms of P and pi. Write down in terms of P and pi the largest area of the largest circle, area of the largest circle in figure 3n. So basically, what does that mean here? Is that your n equals 3p, not 3p, not 3n, 3p. N equals 3p. And the formula for the largest circle is what? Formula for the largest circle is this one. This one. Right? See that? So the n equals 3p. So the formula is n squared pi, right? The formula is n squared pi. So we can say i.e. n squared pi. And this is n is 3p, so it becomes 3p squared pi, which then works out to 3p squared pi, which becomes 9p squared pi. Now if you leave this as the answer, they give you the marks. If you use 3p squared pi, they give you your marks. But expanded, that is it. Very good. That is it. All right, that finishes that question. Let's move to number 8. Number 8. For the geometry is like functions. Question says, straight line x equals 5 minus 3y intersects the x-axis at P and the y-axis at Q. Determine the coordinates of P and Q. Coordinates of P and Q. So for P, on the x-axis, P, on the x-axis, the y is equal to 0, don't it? So that P on the x-axis, the y is equal to 0. So you plug the y equals 0 here, so you get x equals 5. That's all. And at Q, the x is equal to 0 because Q is on the y-axis. the x is equal to 0. So the x is equal to 0 right here. You're gonna get 5 minus 3y equals 0. Or you're gonna get 0 equals 5 minus 3y. So transpose the 3y over here, you're gonna get 3y equals 5. So the y equals 5 over 3. So this point P, the x value is 5. Put it first in the bracket, 5, and the y value is 0. This value at Q, this point Q, x value is 0, and the y value is 5 over 3. That is the answer. Very good? Are okay with that?
Yes, sir.
All right, next part says, calculate length PQ, giving the answer to 2 decimal places, PQ. Quite easy, let's look at sketch and show you. If you have a line, and the line is like this, crosses the x-axis at 5 down here, means that this length is 5 enough. That length is 5 enough. And crosses the y-axis at 5 over 3 up here, means that this length is 5 over 3. All right? So let's put it on. It means that that point is 5, then this length is 5, and this length is 5 over 3. I'm trying to find the length of PQ. This is P, and this is Q. So this is Pythagoras' theorem right there. See that? Becomes the square root of this side square plus this side square. No, so Pythagoras' theorem, right? I'm trying to find the length of this line across here. Pythagoras' theorem. Keep it simple. So PQ is simply the square root of 5 squared plus 5 over 3 squared. Pythagoras' theorem, because I write on a triangle. We don't need to go to no formula. That's it, simple as that. All right? So I wrote that out to the calculator because I said 2 decimal places. I said 2 decimal places, so we're working it out with the calculator. All right? So it's the square root of 5 squared plus bracket 5 over 3 squared. 5.2 PQ equals 1 decimal place, 2 decimal place, 5.27 units. That's the length of it. You have to say units. Formula for what? Oh, I don't get a correct answer. Huh? If you miss the points, it no matter. You're supposed to still get the same answer. Go to these two values involved. You're supposed to get the same correct value, that's the same. You can't get a mark for that pass. Let's continue. R is the midpoint of PQ. Determine the coordinates of R. Let's look at it again. Simply, you know, R is right here. See it? So you're going to be half of this 5 to get to it, and half of this 5 over 3 to get to it. Coming halfway. It's not complicated. Halfway here and halfway there takes us to that point. See that? It takes us to the midpoint. So it's half of the 5 over 2 is going to be the x value, half of the 5 over 3. Half of the 5 is the x value, half of the 5 over 3. That gives us the midpoint. We don't have to complicate it. That is a formula. Nothing. Don't I use a formula? You can use those 2 points. But it's simple. So the midpoint down here, R, is half of 5, which is 5 over 2, and half of 5 over 3, which is 5 over 6. But understand that?
Yes, sir.
Half of 5 and half of 5 over 3. Because the halfway marks is on the diagram here. I sketch it for you. Right? So if you want to come to the midpoint, you come half this distance and half of this distance. Half of this distance is 5 over 2. Half of this distance is 5 over 6. Half of 5 over 3 is 5 over 6. So this is 5 over 6, and this is 5 over 2 to get to this point. So those are the coordinates. It's not complicated. I'm not going to do it difficult, it's easy. Don't make no sense. We do it difficult if it's easy. All right, that's it. Not going to do it difficult if it's easy. That's it. Functions now. This question says, function f and g are these. Let's write it out. So basically f of x is 5 minus x and g of x is x squared minus 2x minus 1. It says the graph of f of x and g of x meet at m and n. Determine the coordinates of m and n. So basically I have to solve them simultaneously. Like you have two equations and then solve them simultaneously. So it's like, yeah, if instead of f, I could put y right here for the f1, y right here. And instead of the g, I could also put y for this one. This is still the f function, this is still the g function, you know. So I'm solving them simultaneously. So at the point where they intersect, the y values are the same. And therefore, this becomes equal to this. That's the easy way to look at it. The y values are the same. So at the point where they intersect, this equals that. Right? So at m and n, f of x becomes equal to g of x. Two functions meet. So this becomes equal to that. So x squared minus 2x minus 1 becomes equal to 5 minus x. So you have a quadratic to solve, but it's not in a standard form. We need to leave 0 alone on the right side. So we're going to transpose the x and add it to that. So we're going to get x squared. Remember this x and add it to that. We're going to get negative 2x plus x is negative x. Bring this 6 5 and add it to that. From negative 6. Negative 1 and negative 5 is negative 6. Equals 0. This factorizes easily because that's 3 and 2. And the difference is the 1 inside there. So this factorizes easily. X and 3 and 2. Signs in the bracket are different. The larger one, the negative sign, the larger product. Far product and the near product. The larger one is the 3x here, make it negative. Negative here, positive here, this equals 0. So this factor equals 0. They say that the x will be 3. X equals 3. If this factor here equals 0, then x is going to be negative 2. X equals negative 2. So those are the x values where they meet. We need to find the y values. We're going to plug this 3 into this line right here. Find the corresponding y value. And plug this into the same line. Find the corresponding y value. Don't bother plug it in the curve, it's more work. So that. So I'm going to say, and this one, this one, the y value is 5 minus 3. I plug the 3 right here for the x. 5 minus 3 is negative 2. And this one, I'm going to plug the negative 2 in here again. So I get 5 minus 2, sorry, 2. 5 minus 3 is 2. Thanks for that. And I plug the negative 2 right here. So I get 7. Y equals 5 minus a negative 2. So y equals 7. So this point is 3, 2. And this point is negative 2, 7. Which one am I going to give m and which one I'm going to give n? Since this one has the lower x value, I'm assuming it comes first. I'm going to give this one the m and give this one the n. But I don't think it really matters. Those are my answers. Very good. I'm solving them simultaneously. It don't really matter which one I give. Since the m comes before n, I put the one with the lower x value for the n. Those are the answers. This and that. So it's essentially what you did in this question was solve the equations simultaneously. All right. Next question. A velocity time graph, speed time graph. Question says Monty is cycling at 12 meters per second. See there, 12 meters per second. He's going at 12 meters per second. It says after 4.5 seconds, right here. See there? After 4.5 seconds. So I'm going constant first, you know. But then after 4.5 seconds. And he starts to decelerate. See, he starts to slow down, cutting his speed. Here, so he's cutting his speed. He starts to decelerate, right? And after a further 2.5 seconds, he stops. See, stop right there, son. Stop. Right? So the graph is showing what they are saying up here. Up here, the graph is showing what up here is saying. All right? Decelerate. And I'm assuming that is a constant deceleration because it shows as a straight line. Uniform deceleration. Question said, calculate the constant deceleration. Gradient on a speed time graph is acceleration and deceleration. Acceleration is rise over run. Deceleration is fall over run. But deceleration, you're cutting your speed. So deceleration is fall over run. Because you're cutting your speed. And deceleration already means negative acceleration, so you don't put a negative on it. All right? So the deceleration is fall over run. If it was a line going up this way, and I want the acceleration, it will be rise over run. Because acceleration is gradient on a velocity time graph. Positive gradient, rising gradient. Deceleration is falling gradient. All right? But the speed is falling. So it's fall over run is deceleration on a speed time graph or a velocity time graph. So we're gonna write the deceleration is fall over run, and the fall is by 12 meters per second, don't it? And the run is 2.5 seconds. See that? 2.5. That's all. 1, 2.5. They said it in the question as well. 2.5. 2.5. Write that out for me. 12 divided by 2.5. Eh? 4.8. 4.8, and you have to say meters per second squared. Deceleration is the same unit with acceleration, meters per second squared. Huh? You can write it like this. You can write it as 4.8 meters second to the minus 2. You can write it like that as well. Write it like this or like this. But the reason I use this one because they gave me like that. Understand? But if you put ms to the minus 2, they give it a mark just to see it. Alright? So this is also correct. If you wrote it like this, that's fine. But let me put or right here. So or. We'll write it like this as well. 4.8. Wanna go to that? Alright. It says Monty's average speed over the 7 seconds. Average speed over the 7 seconds. So it's for the whole journey, 7 seconds. It is the total distance over the total time. Distance on a speed time graph is the area under the graph. So if we want the total distance is the area under here. The area under here. Total area under here. Area on a speed time graph is distance. All right? That's a trapezium, don't it? These are the parallel sides.
Sir, yes, sir, that's interesting.
Good. Up here says 4.5, under here is 7. The distance between the parallel sides is 12. See that? It's a trapezium. So let's write it out now. See here? The average speed is equal to the distance traveled over the time taken. The distance happens to be the area under the graph. Over the time taken is 7. And what is the area? Okay, I work on the area right here. So the area is the area of the trapezium. Half the sum of the parallel sides. Parallel sides are 4.5 and 7 multiplied by the distance between the parallel sides, which is 12. That gives you the area, which is the distance traveled. What is work out to? 69? 69 meters is the distance traveled. We're going to put this up here, so now, bam. So this works out to be 69 over 69. 69 over 7, which is what? 9.86? 9.86 meters per second, the average speed. So the average speed is equal to that, guys. Work out the distance here. Huh? It's what? You could write it like this. You can write it like this, or you can write it like this. ms to the minus 1, no matter how you put it. Either write it like this, or you write it like that. Because the question gave it to me like this up here on the graph. See? That is why I'm giving it back to them in this format. If the question gave me like this up here, ms to the minus 1, then I would give them back that format down here. See? But it really matters still. It's irrelevant, really. Right? So we could write 9.86 meters per second. Meters per second like that as well. So we could have written this as well. You can say over. But I go to that. Alright, so I'm going to change this color since we calculated the area right here. Done. Alright. Next question is number 10. Number 9, sorry. Which is a circuit theory question. So you have to remember the several rules in a circuit. I think I'm going to do one of the sessions with circuit theory.
Sure.
I want to do some circuit theory. I'm going to do some circuit theory one of the sessions. Okay?
Sure.
Circuit theory is on every paper, you know, so kind of makes sense. Yes? Somebody online have a question? Somebody have a question? All right, no.
No, sir.
All right, cool. So this question says, in the diagram below, A, B, C, and D are points on the circumference of a circle with center O. So this is center O. It says BOD is a diameter. That's a diameter. Remember now, angle subtended by a diameter at the circumference is 90 degrees. So over here, so it's 90 degrees. You know? Angle subtended by a diameter is 90 degrees. Remember these things. Right? This is also a diameter if I pass through the center, right? This is also a diameter. This line, the diameter.
Sure, so B is also 90.
Good. It subtends 90 up here as well. Good. So up there, so it's 90. It means that them two angles are up to 90, you know, them two there, don't it? Huh?
Yes, sir. Yes, sir. They're complementary, right?
Good. Complementary angles. Lovely. All right. It says AB and CD are parallel. So you see these are parallel lines. So once you have parallel lines now, you're thinking of your Z angles and your co-interior angles. So for example, this line now will give us a Z. This angle
yes,
and this
sir.
angle will be the same if I wanted it, right?
Yes, sir.
But also, this line and this line parallel. This one is a transversal line connecting them. So this angle and this angle equal, don't it? Yes. Those are also alternate angles, Z angles. All right. All right, let's see what I want us to do. It's a state a reason why angle ABC is 90 degrees. Up here. Subtended by a diameter AC, right? So let's write that. Subtended. It is subtended by a diameter AC. That is why it is 90. It's subtended by the diameter. The diameter AC, right? It's subtended by the diameter AC. That is why it is 90. Because angle subtended by a diameter is 90 degrees. You have to know the rules. All I know that topic here. That topic here from January. So most know them rules I know in last year. From December, yeah, from December. All right, so most know them rules are by now. Next question says, determine the value of each of the following angles, show detailed work in where necessary and give a reason for your answer. Angle BAC, let's look at the diagram. Angle BAC, angle BAC, they're asking us for this angle, right? So we need to calculate 2P. To calculate 2P, we need to calculate P first. We are going to use that these two angles are complementary angles. Them two there add up to 90. So 5P equals 90. Let's tell the examiner. If we go to the examiner and say 2P plus 3P equals 90 degrees. All right, complementary angles. Let's shift it over. All right, complementary angles. They are complementary angles. It means that 5P equals 90 degrees. So P equals what? 18 degrees, don't it? And if P equals 18 degrees, it means that angle that we want, which is BAC, is equal to 2P, which is equal to 36 degrees. So it's 36 degrees. That's it. But God?
Yes, sir.
36 degrees.
Yes,
2P
sir.
is 36 degrees. All right. Next question.
Sir, that means,
yeah?
sir, sorry for interrupt, sir. I mean, so we know what R is too, sir, because the alternate angles, we know that R is also 36.
R is also
If you look
36 on the
back
diagram. Yes, that's it. But let me ask us for it. Yes, because we have the alternate angles here. So this and this equal. Yes, R is also 36. Yeah, that is correct.
Yes, sir.
R is also 36. All right, let's do what I want us to tell them next. They want angle Q next. So let's look at the diagram to where angle Q is. It's right here. Now these two angles equal enough. Why are they angles? Same segment rule.
Oh, angles in the same segment are equal.
Good. Angles in the same segment are equal. Both of them are subtended by this chord right here. This chord is subtending the 2P up here. The same chord is subtending the Q up here. Same red chord. Subtending those two angles. So Q equals 2P, which is 36, right? Same segment rule. So the Q right here, we're going to write equals 2P, which is 36 degrees. I'm going to write angles in the same segment are equal. That's not the only reason. You could find another way, right? You could find another way. They wanted to write the reasons down here, guys. You can write it down here. But I'm sure if you write it here so you get the marks just the same, no matter. It's human beings marking the paper, not machine. So we will write it down here, so no problem. You can write on there. I just don't like to write in the lines, right? Prefer to write in the space. So you write it down here if you have to make something in the exam. All right, what else they want us to find? They want us to find angle R. But angle R was also 2P for alternate angles.
Yes, yes,
right. Or we could say, another way we could say it, you know. We could also say this. We could also say that's an isosceles triangle.
Oh,
it's an
yes,
isosceles
sir.
triangle, you know. So these two angles equal, see it? So multiple ways you can, right? So R equals Q as well, right? Isosceles triangle. So R equals Q. So angle R equals Q, which is same 36 degrees. And we can say angles in isosceles triangle, right? Angles in isosceles triangle. That's isosceles triangle. Angles in isosceles triangle. Angles in the isosceles triangle. All right, these are the equal angles in the isosceles triangle. All right, so that is that. Next question, bearings. Question says, from a harbor H, the bearing of two buoys, S and Q, are 185 degrees and 315 degrees respectively. Bearing of two buoys, S and Q. So from H, we're going to this one and to this one. All right? So from here to here, it's a 185 degrees. See here, so from the north line, I'm choosing have to turn to the right to face S. And so the one that I didn't show, we're going to show it on the diagram. This is the north line at the front position. So we'll angle all the way around here to Q. To face up at Q. This angle is 300 and what? 300 what them say? 311 degrees. Good? So it means that the angle inside here is the difference between 311 and 185, don't it? All right, so we can work that out from now. So the angle inside here, let's work it out, is 311 degrees minus 185 degrees. How much is that? 126 degrees. So this is 126 degrees inside there. All right, let's see what they said. It says Q is 5.4 kilometers from H. That's this distance. Let's put on the diagram, 5.4. 5.4. Put it on the diagram. And S is 3.5 kilometers from H. So this distance, 3.5. So a classic case now, two sides and an angle between. Cosine rule if we want to find this side now, right? Question says, on the diagram below, which shows a sketch of the information, insert the values of the marked angles. Mark angle QHS, that's inside here. It's 125, right? 126, right? That's what we worked out here. I would just need to show it, and it's on the diagram now, 126. Next question says, calculate QS, the distance between the two buoys. So we're going to use cosine rule to calculate that, right? So using these two distances and this angle, that's all. I'm dropping them in the cosine. Let's write them down. We're using the 3.5, using the 4.5, and the 126 degrees. See that? That's what we're using in the cosine rule. Ready now? Huh? Oh, 5.4. What? Sharp. Wow. Sharp eye Washington. 5.4 and 126. Sharp eye Washington, man. Already. So cosine rule we're using. Cosine rule. Cosine rule for QS. Ready? Let's write it out now. QS equals, start like Pythagoras' theorem as usual. Always start cosine rule like Pythagoras' theorem. Square root of 3.5 squared and 5.4 squared. Remember, in the cosine rule, the length of the side is less than an hypotenuse, right? So you have to subtract a piece. So you subtract 2 times the 3.5 times the 5.4 times the cosine of the angle between, which is the 126. And everything is under the square root sign, and so you calculate QS that way. All right, so we can go for the calculator and calculate QS that way. All right, so square root 3.5 squared plus 5.4 squared minus 2 times 3.5 times 5.4 times cosine of 126 degrees. Make sure the calculator is in degrees up there. So the DEG, make sure the calculator is in degrees. You get 7.98, 3 significant figures. 7.98 kilometers. 7.98 kilometers. Them say calculate the bearing of S from Q. Let's look at it. Always make sure you note the from position. So I'm going from Q to S. So the bearing has to be taken at the from position. Always make sure you note your from position. You calculate the bearing at the from position. So it's from Q to S. Go on the diagram, show the angle on the diagram, and see how we're going to work it out. All right? From Q to S, it's 3 marks in it, so it means that we're going to have to do some work. All right, so not one that we're going to look and know, right? From Q to S, go on the diagram and show it on the diagram. So we're coming from here to there. All right, let's see now. Draw the angle that you want. What this side was what again? More than we're going to use it. It was what? 7.98? 7.98 kilometers. All right, we're going to show the angle now. So at the from position, we're going to show the north line. right here. This is the north line we're measuring the bearing from. And this is the line that we're measuring the bearing to, right? So you draw the clockwise angle to that line around here. Let's call that angle theta. That's the angle that we want, theta, right? More than likely, the angle inside the triangle will play a part in the calculation. Right here, you're going to mark it as alpha. Will play a part in the calculation. I think I see it already now. It is sum of alpha and this angle right here. Don't it? And that angle is co-interior with this angle right here. What is that? That angle is co-interior with that angle right here. All right, so we're gonna work out this angle inside here. So first, this angle inside here, so it's basically 360 minus 311. Remember, 311 was up to here, and 360 would have gone all the way around. So it's 360 minus 311. That's 360.
49.
Right,
Equal
minus
49.
311, which is 49 degrees. So that angle is 49 degrees. Then it is co-interior with this angle up here. They add up to 180. Let's mark that angle in a different color. Let's mark it in a different color from the blue. Just to make it stand out. All right, just to make it stand out, let's mark it a different color. So this angle that we want right now is this purple angle right here. This purple angle is co-interior with this angle down here. So this purple angle is 180 degrees minus 49 degrees, which is how much? How much?
131.
151? 131?
131. Yes, sir.
131 degrees. So we need alpha, right? We're gonna add 131 to alpha, that we're good. How are we gonna find alpha? We're gonna use sine rule. Why sine rule? Because we know of a side and an angle opposite each other. We know both of them. Once you have that, you're gonna use a sine rule. So we're using these two with these two in the sine rule to find the alpha. So it's gonna be the sine of alpha over this equal the sine of 128 over that. All right, let's set it up for the alpha right here. Let's do it right here. So let's write the sine rule for the alpha right here. Or we're gonna find it. And then we'll carry it down the bottom and use it, right? So sine rule for alpha, sine rule for the alpha. It's gonna be sine of alpha over the side opposite the alpha is 3.5 equals sine of the angle we know, which is the 126. Over the side opposite the 126 is 7.98. And to find the alpha, we're going to multiply with 3.5 first and then take the inverse sign, right? So the alpha is going to be sine to the minus 1 of the 3.5 sine of 126 degrees over the 7.98. And that's going to give us the alpha. But understand that? That's going to give us the alpha that we need. So let's do it right here. So we're doing sine to the minus 1 of a fraction 3.5 times the sine of 126 degrees divided by 7.98. That's 20.8 degrees. So the alpha is 20.8 degrees. So to get the bearing, we're basically adding the 131 and 20.8. See that? Good. So down here then, bearing of Q from O. See here now? See here now? I tell the examiner, bearing of Q from O is theta on the diagram. The theta angle on the diagram is equal to 131 degrees plus the alpha. It's 131 degrees plus the 20.8 degrees. I'm going to add 131 to this. I'm going to get 151.8 degrees. But because it's bearings, we tend to write 3.
They roll it off, sir.
152 degrees. That's it. Yes, that's that. Very good. But okay.
Yes, sir.
Run it out for me, please. Put 3 digits. The exam not come yet. So if you do this, fine. But I want you to do this. Always give me 3 digits for bearings. If the angle come out, for example, to 51.7 degrees, you have put 0.52 degrees for your bearing. You understand? You have to put 3 digits. You normally try to put 3 whole number digits. All right? So if it's 2 digits, you put the 0 in front. All right, good. That's how we represent bearings. That finishes that question, guys. Let's move on to the last one. What time is it now?
126.
Yeah, 126. I'm saying we could do some one topic before we finish, before we leave. No, lazy, you know. Lazy, you know. It's not from paper 2. Huh? It's not coming on paper 2. Already, last question. Last question. Hey, all right, ready. Last question. Hey, ready. This question says the matrix W is this one. And it said we have to determine 2 by 2 matrix L such that W plus L is 0, 0, 0. So basically, what matrix will negate all of these values, don't it? And make them 0, that's all? This is called a null matrix. All the values 0. So L has to be, we're not going to calculate nothing, you know. The negative of this is -3, negative of this is -6, negative of this is 2, negative of that is -5. Good? Must be that. All right? The value matrix that will negate all of these and make them 0. All right? Next question. Must find the matrix P such that WP is equal to this. What is this matrix called? The identity matrix for multiplication of matrices is I. And what do we know? When the product of 2 matrices equals I, the matrices are inverses of each other. Don't it? Like this. M times m to the -1 equals I. So it means that these 2 matrices are inverses of each other. We're not going to do it any other way. So it means that P is the inverse of W, don't it? Don't it? P means that the P that we want is really W to the -1. That's all. What is the W again? The W is this guy right here, right? Let's write it closer. The W is the matrix 3, 6, -2, 5. So calculating the inverse of it right here. It is 1 over the determinant times the adjoint, don't it? 1 over the determinant. What's the determinant? Determinant is this product minus this product. Let me change this color so it can stand out for us. Let me change this color. All right. So again now, the determinant is calculated using this diagonal product minus this diagonal product. I will be careful with these negative signs. All right, ready now. So this product is 15, note it. 15 minus this product is -12. -12. So that's a plus. So I'm going to write what them equal to under here so I don't forget. 15 and 12 is 27. So under here is 27. That's the determinant is 27. I'm multiplying that by the adjoint matrix. The adjoint of the W matrix. Interchange the element on that first diagonals. Interchange them, switch them around. So the 5 will go up here and the 3 will go down here. All you do is switch them around, don't change the sign. Then leave these 2 on the second diagonal, leave them where they are, change the sign. So this 6 becomes a -6. This -2 becomes a +2. And so the P now is obtained by dividing each of these by the 27. So we can write them as fractions like this. P equals 5 over 27, -6 over 27, 2 over 27, and 3 over 27. 3 over 27 is 1 over 9. But we can leave that still, no problem. And this is my inverse. That is the P. Everybody good? Online, everybody okay? Remember, when the product of two matrices equals the identity matrix, they are inverses of each other. So if you know one, just calculate the inverse, and that is the other. Cool? All right. Next question. It says, a right angle triangle M has vertices 1, 1, 3, 1, 3, 4. When M is transformed by this matrix, the image is M prime. What transformation is that matrix? What transformation is that matrix? You have to know it on site.
Sir, the reflection in the line equal y equal x.
Good. It's a y equals x reflection matrix. This is a y equals x reflection matrix. Y equals x reflection matrix. What happens to your coordinates when you're reflecting line y equals x? What happens when you're reflecting line y equals x? Switch around.
Only.
So xy will go to yx. You see, these I'm writing on the paper. I'm leaving it on the exam paper. I'm in the exam. I'm going to leave this that I wrote on the exam paper, telling the examiner what I'm going to do. I'm not going to calculate anything. I'm just going to switch around these values and write my answer. Because they cannot penalize you for having advanced knowledge. You understand? You cannot be penalized for having advanced knowledge. Make people who don't know calculate it. You understand? So I'm going to write that the coordinates of M prime, which is the image, coordinates of M prime, X prime is going to be 1, 1 just the same, don't it? Because we switch on 1, 1 is still 1, 1, don't it? Y prime becomes 1, 3, don't it? And Z prime becomes 4, 3, don't it? That's all. That's it. If you want to be generous to the examiner, you can give him a little general calculation like this. You can give him a little general calculation and show what happens to a general point. So you can say 0, 1, 1, 0. When you multiply with a general point xy, it becomes equal to a general point yx, which means that xy is mapping onto yx. So if you want to give him a little thing like that as a general and say this is general, give me what this is general what happens, a general point. And that's what we did here. We applied it general to all. We applied the general to all other points. What happens to a general point will happen to all other points. You understand? Good. So if you want to be generous and give him that, they can do that. That's it. 2 marks for that. Next question. Vectors. Vectors next. Question says, the diagram below shows triangle OPQ, and it says OP is the vector 3U. Right up here says 3U. And they're helping us. They break it down for us into 2U and U. So they're helping us in the diagram. OQ is the vector V right here. This here is the vector V. It says Q is the midpoint of OR. So Q is the midpoint of this line. It simply means that we're talking that since this vector is V, then the vector from here to here is also V. Same length and same direction. I'm going to put it on the diagram. Right here is also V. So all the way out here is 2V. V plus V is 2V. All right? Next part says, M is the midpoint of PQ. So M is right here, is the midpoint of PQ. It means that PM is half of PQ, don't it? PM is half of PQ. It says we have to calculate the vector LM from here to here. So how do we go from here to here? Easy. Come up to P and then go down to here. So in order to find the PM, we need to find PQ first, don't it? So let's find PQ over here, because they didn't ask us first. Let us find it over here. We need it. So PQ over here will be equal to, how can we go from P to Q? Easy. We can go P to O and then O to Q, don't it? Another way we can look at it is to say, since we know the position vectors, we can calculate it and say O times the last minus O times the first. See that? OQ minus OP, because we know them. We know the OP and we know the OQ. So when you know the portion vectors, you can calculate. You have to use the diagram. So this will basically give us V minus 3U, which is the same thing as minus 3U plus V. Why is it minus 3U? Because we're going in the opposite direction to the U direction. All right? That's why it's minus. So then now we need half of this value, half of that for the PM. So let's write it out. So this LM is L to P and then P to M, don't it? The L to P is U, don't it? Right here. And the PM is half of PQ. Let's write it on the side. The PM is half of the PQ. So let's put this on the side for the examiner. So we're taking half of this right here, so don't it? So it becomes half of the V. So it becomes half V. And then half of the minus 3U is minus 3 over 2U. Minus 3 over 2U. Then we consolidate the like components. This is a U minus 1.5U. Okay, I'll put by the half V first. Half V. Then a whole U minus 1.5U. Or I'll put another way. We can write this U as 2 over 2. So it has the same denominator as that. And it is 2 minus 3. See that? Minus 1. So it becomes minus 1 over 2U. That is what it is. Minus 1 over 2U. That's LM. Next question says, we are to calculate PR. Let's look at the diagram. P to R. We're going from P to R. This one easy. Come down, sir. Minus 2U. Go straight across, so 2V, don't it? P to R. So minus 2U plus 2V, don't it? Same as 2V minus 2U, right? 2V minus 2U. Good? So we can just write it. 2V minus 2U. Easy. Huh? Minus 3, sorry, minus 3. Minus 3U. All right, thanks for that. Minus 3U. Yes, 3U. Minus 3U plus 2V. All right, good. Minus 3U plus 2V. Minus 3U plus 2V. Minus 3U plus 2V. So this is equal to minus 3U plus 2V, which is same as 2V minus 3U. One more for that, okay? Easy. All right, next part now says, show that these points are collinear. Remember, to show that they are collinear, you need parallel vectors with a common point. You have to show that you have 2 vectors among these 3 points that are parallel, then one of the points will be a common point. So you need to determine which 2 vectors you're going to use. So let's look at what we have already. So it's L, M, and N, right? When you use LM, these points you're talking about, these points, right? I'm going to use, not going to use MR, man. I'm going to use LR. LR is easier to find. LR is easier to find. Minus 2U plus 2V, that's all. So LR is easier to find. So we're going to use the LM that we have, this one. So let's write it out. We're going to use LM, which is half V minus half U. I'm going to use this one. Stop talking, please. Stop talking. Hello. Stop talking. I'll go outside. I'm going to use this one. And for the diagram, I'm going to use LR. LR is easy to find because it's just minus 2U plus 2V. Same as 2V minus 2U, right? Minus 2U plus 2V. Minus 2U plus 2V, which is same as 2V minus 2U. So LR is 2V minus 2U. So I want to show that these 2 vectors now are parallel. right? We want to make them equal. I can multiply that one by 4 now. It becomes equal to that. You see it? Don't it? I multiply this by 4, it will become equal to that. So we can multiply this one by 4. Multiply by 4, I'm going to get 4ln equals 2v minus 2u. And then these two things equal now. This and this equal. So, oh, I need a 4. Left out the 4. Left out the 4. 4. Multiply by 4. Multiply this by 4 as well. Right. So then these two things now are equal. This and that equal, right? So we're going to equate. So I'm going to write the equate. So we're going to equate them because them equal. So we're going to get LR equals 4LM. LR equals 4LM. Okay, underline the common point, which is L. And then state the conditions now. Condition 1 is that the vectors are parallel, don't it? LR is parallel to LM. So we have parallel vectors. Second condition of a Coulomb theory is a common point. L is a common point. So tell the examiner, L is a common point. So because you have that, it means that the points involved are collinear. So you write the conclusion. Therefore, L, M, and R are indeed collinear. And that is it. 9 marks in those. Oh, it no matter. Once you still get it, you're good. That is it, guys. Any two vectors between the 3 points can be used. Any two vectors from the 3 points can be used. So you use M as your common point. That's still correct. All right. Any two vectors can be used on the 3 points. All right. What do we do now, guys? I'm saying we could run through the papers. We take a break. We take a short break. What time is it? I said we're gonna go to 3 o'clock today. I don't want the next hour. Huh? Lazy, you know? All right. Quiet. Let's see the people online. Students online, do you want to do some more work?
Yes, sir. Definitely. Yes, sir. Definitely.
Go away. I said we're gonna go to
in like 2 days, sir. Why not?
Hold on.
Nothing to lose, sir.
Hold on. Can't hear. Hold on. Can't hear. No, well, it's recorded enough, so you can't watch the video if you don't want it. It's recorded. Let me hear what you say you want to do.
Let's do some work, sir.
Huh?
Let's do some work, sir.
Do some work.
Yes, sir.
All right, okay now. Hey. We're going to do the session of a quiet now. So who want to leave? Leave now. I'm going to work on that. I'm going to work the trap. So those who want to leave now. You can send me your remarks later. I did promise that I was going to do the session up to 3 o'clock. So persons join, expecting for me to work till 3 o'clock. So let me take what time is it now? Let me take a 6 minutes break. I'm taking a 6 minutes break. So I'm starting back at 1:50. So I'm starting back at 1:50. Okay? Starting back at 1:50, 6 minutes break. All right, guys. Gonna start back now. We're gonna do a couple more questions, maybe one or two topics. See if we can cover one or two topics on the 5 people we were working yesterday until about 3 o'clock, about another hour. Tomorrow, instead of starting at 9 p.m., I'm actually gonna start this at 5 p.m. tomorrow, Jamaica time, 6 p.m. Trinidad time. All right. So I'm just gonna have a class here set up. I'll just continue the same thing we're doing. All right. Trying to go through those 5 papers. All right.
Yes,
Want to complete all the questions on those 6 papers that we're focusing on. All right. So I'm saying what we could do is we can maybe do the number. Let's do the number 8 question on the paper now, which is usually quadratics or functions or whatever. So we're gonna do the number 8 question on the paper, on all the papers, all right? So the first paper was the January 20, this paper. We're doing the number 8 question. All right, number 8. Okay. Focusing on number 8. Where are we? Oh, it's weird on number 2. Number 8. All right. So we're doing the number 8 questions on these 5 papers. It's our revision. All right. So this question is a functions question. It's part of it. Give us these 3 functions: f of x, g of x, h of x. 3 functions. Question wants us to find g of x minus 2. So g of x minus 2 means that we're going to plug the x minus 2 into the g function right there. That is all. Plug in x minus 2. Normally they give you a value like maybe g of 2. And you plug the 2 in there. So if it's x minus 2, it's basically the same process. You're going to plug x minus 2 in there. So this is going to be equal to the g of x minus 2. It's going to be, you put in x minus 2 right here. It's going to be x minus 2 squared minus 5. So where the x is, I put x minus 2 there. And I will basically working this out. All right? So we can expand that to the perfect square. Remember, we expand the perfect square 3 terms. First term squared is x. Twice the product of the 2 is the middle term. Then you multiply them first, again, negative 2x. They double it to negative 4x. I need a square on this. Negative 4x. And the second term squared is 4. And you're subtracting this 5. So it works down to x squared minus 4x minus 1. That is it. All right? That is it. Next part wants f to the minus 1 of 11. Find f to the minus 1 of 11. We're going to find f to the minus 1 of x first. Don't prep, I'm Mr. America. Yeah? So we're going to find f to the minus 1 of x first. We're going to start by saying f equals 4x minus 1. And then we're going to inverse it first. Inverse it first. So the f becomes x. And this x becomes f to the minus 1 minus 1. I want to make this a subject. I'm going to carry over this negative 1 first and get x plus 1, and then we're going to divide under the 4. Divide under the 4. That leaves f to the minus 1 of this as a subject. Now that really is f to the minus 1 of x. This is really f to the minus 1 of x. We try to find f to the minus 1 of 11, so let's do it here. So we can say, therefore, f to the minus 1 of 11 now means that we substitute 11 inside here for the x. And so it becomes 11 plus 1 over 4. This is 12 over 4. 12 over 4 is 3. So this works out to be 3. That is the answer. F to the minus 1 of 11 is 3. Next question. Wants us to find h of 1. H of 1. It means that we're going to find the h of 1 here first. So this is the same as h of 1. How do we find h of 1? By plugging the 1 in the h function here. Remember the h is 3 to the x. The h is 3 to the x. Let's write it. The h of x is 3 to the x. So h of 1 means that we're putting 1 up here. So this then becomes h of 3 to the 1. 3 to the 1 is 3. So we're doing h of 3. So this is h of 3. Then h of 3 number means I want to put the 3 up there. And so it will become 3 cubed. The 3 cubed is 27. So the answer there is 27. All right? But good online?
Yes, sir.
But okay? All right. Next question. Functions again, but this is now quadratics. Quadratics, all right? Question says this function f is defined as that. That's a quadratics. It says complete the table below and plot the graph of f of x equals that. Now remember, a quadratic is a symmetrical graph. This one, because the square term is positive, is going to have a smile shape, and so it has a minimum point, minimum vertex point. All right? The values are symmetrical, so we can actually look at the table and see the values. Now, since there's a 0 here, there's a 0 here, these values are all in the same interval, increasing by the same amount, same value, increasing by 1. So the values are symmetrical. To the right of this 0 is a 4. So the left of this 0, this is going to be a 4. And then to the left of this 0 is a -2. So the right of this 0 is going to be a -2. So I can know the values by the symmetric nature of the function. So I can plug those in. But you can also calculate it by plugging the -2 in here. You plug -2 in there, you're going to get this 4. Right? Like so. It will be -2 squared minus 2 minus a -2 minus this is minus and -2 and then minus by the 2. This will work out to 4. This will become a positive 4. Why is this not working out? Minus a -2. -2 squared is 4. And I'm getting a +2 or +2, but a +2, and then -2. So this is why I put that and I get a 4. So that's how I get the 4. All right. Or if I wanted this one, I could plug the 0 in there and there. And the answer will be -2 as I have it here. But because the values are symmetrical, I could write these values in by observing the values and using the symmetric nature of the values. Now, this graph has an axis of symmetry. I have to be careful. You notice these are your two lowest values, -2, -2. And they come in between the 0 and the 1. So your axis of symmetry is right in between here. It is that x equals half. X equals half. So the lowest value of the function really occurs at x equals half. So to find that lowest value, you plug the half in here to get that lowest y value, which is the minimum value. Right? So this is the x value at the minimum point. So you plug the half in here, and that will give us the minimum value. So let's do it over here. X equals half. The y becomes half squared minus half minus 2. This becomes a quarter minus half minus 2. Somebody write this out for me now. What does it become? -2 1/4. Because this becomes -1/4. So it's -2 1/4. So it's -2.25. So here is -2.25. So when the x is a half, at the vertex point, the y value is -2.25. So the minimum point is half -2 1/4, -2.25. All right, so we need this point to know where the turning point is. I want to draw it on a graph. All right, we have to understand the nature of the quadratic function. They don't want us to plot the points and draw the graph. Notice they didn't give us this point, They want to give us these points. But you have to recognize that they have a vertex point right in between these values, where those two low values are. All right, so what are the points to plot? -2, 4. Let's plot them. -2, 4. Well, they didn't give us any scale, so I want to put on a scale on the graph. All right, so I want to say 2 centimeters is 1. They didn't give us any scale. Did they give us a scale? Oh yeah, sit here. Use 2 centimeters to represent 1 unit on both axes. So they gave us a scale right here. So this is gonna be 1 miserably. So this is gonna be 1, 2, 3. This is gonna be -1, -2. All right. And right here is gonna be 1 on the y-axis, 2, 3, 4. See, it went up to 4. And I'm going down here. This is -1. This is -2. -1, -2. So right here will be negative 2.5. Right? But I need to locate the -2.25. Right? So this is -2.5, -2.5. Right here, -2.5. So -2.25 will be right inside here. -2.25. -2.25. Halfway between the -2 and the -2.5, -2.25. Remember, it was at a half, the turning point was at this point. Half -2.25. Alright, so let me check and make sure this is correct. Let's check something. Yeah, this guy. So the minimum point will be right here. This is half, right here says half. X value of half. And then this is where it turns. So the graph is gonna come and turn here. Let's put it in blue. The graph is gonna come and turn right down here. So that's the minimum turning point right here. We're putting on these coordinates now. So this first coordinate is -2, 4. -2 up to 4. That's right at this point. Right here. The next one is -1, 0. -1, 0 is on the x-axis right here. Right here, -1, 0. Next point is 0, -2. 0, -2 is right here on the y-axis. 0, -2. Then you have 1, -2. So you see it's symmetrical. 1, -2 is right here. So you see it becomes symmetrical about this vertical line, the values. And that is the axis of symmetry. The axis of symmetry. You have 2, 0. 2, 0 is right here. And then I have 3, 4. 3, 4 takes us back up here. And you draw a smooth curve to the point. Now, the thing is, this point down here, we had to calculate it. And I see that's what CSEC does from time to time. They don't give you the minimum point. You have to know that it's a minimum point. You have to work it up. All right? And it's halfway between the values at the axis of symmetry. You want to complete the square and work it that way? You can. But you can work it out by observing the values. It's halfway between here and here. Understand? It's halfway between the 0 and the 1. Because these two are the same value. The minimum value is a vertex value. There's only 1 point it can be at. So it could never be -2. But the minimum value, of course, that's only 1 single point. Understand? Good. So the graph has to come down to here. You could not draw the graph and just go straight across like that. As a curve, it comes down to a vertex minimum point at the axis of symmetry. So we have to understand the nature of the graph. So let's draw a smooth curve through these points now. Remember, don't put any ruler on it. It's a curve. Has to curve. See, it come down and turn there. And then it goes back up. All right. You draw that. CSEC will give you a mark. The important thing is that you have to work out that minimum point here. You understand? You have to work out that point. That is the vertex point right down here. And this vertical line through here now is called the axis of symmetry, or the line of symmetry. It is x equals half equals of that line. Divide the graph in 2 halves. This side is a mirror image of this side in that vertical line, the axis of symmetry. All right. Okay. That's what they want us to do. Let's leave the x equals. That's what they want us to do. Just to draw the graph and we're done. That's it. See? That's it. Finish. All right, so that finishes that question. Next question is number 9. So we're going to do the next number 8. Everybody good? Students online, okay?
Yes, sir.
All right. Let's do the number 8 now. These questions they practice them over. Note they did not give us the minimum point. You have to know that it has a minimum point, a vertex point, and work it out, right? All right. Let's look at the paper, the number 2 paper. Number 2 paper. I don't want that. I want to do this. The number 2 paper. This one. We're going to put the number 8. That's what it gives us. Number 8. So starting at 5 o'clock tomorrow, students online, instead of 9 p.m., we're going to start at 5 p.m. Jamaica time, 6 p.m. Trinidad and Tobago time. So somebody said I wanted a linear programming. Say a linear programming here. Number 8. All right? Number 8. The question says, a rental company has X cars and Y minivans. We want to say X cars and Y vans. Company has at least 8 vehicles altogether. That's it. The cars and the vans is at least 8. At least 8 means 8 or more. So this information here means that X plus Y must be 8 or more. At least 8 means greater than or equal to 8. That's what that information means right there. All right? It says the number of minivans is less than or equal to the number of cars. The number of minivans is Y. The number of minivans is Y. Them say it is less than or equal to the number of cars, which is X. Number of cars, which is X. That's the next piece of information. The second piece of information. The number of cars must be no more than 9. No more than 9 means that 9 is the max. There may be 9 or less, not more than 9. So the number of cars, which is X, can't be more than 9. So it can be 9 or less, means less than or equal to 9. And the question says, write 3 inequalities in terms of X and Y other than these 2 to represent information. These are the 3 inequalities based on what they just said. So that's what I want us to write. X plus Y greater than or equal to 8, Y less than or equal to X, and X less than or equal to 9. That is it. All right? That's the information they want. Next question says, a car can carry 4 persons and a minivan can carry 6 persons. There are at most 60 persons to be taken on a tour. Show that this is true. 2x plus 3y less than or equal to 30. Now remember, a car can carry 4 persons. There are X cars, so this is 4 persons times X. There are X cars. And this is 6 persons times Y. But there are Y minivans. And the total number of persons at most is 60. That means less than or equal to 60. So the total number of persons is 4x, 4 times X, plus the persons in the van, which is 6Y. That total number of persons can't be more than 60. It's at most 60. So it has to be 60 or less. We divide this 2 by 2. Divide 2 by 2. Because it can be divided 2 by 2 to simplify it. And so this becomes 2x plus 3y. Go back for the blue. 2x plus 3y is less than or equal to 30. And so we show it, right? That's information. Nice and easy. In your program, somebody wanted it last. Next question. It says on the grid below, plot the 4 lines associated with inequalities and shade and label the region which satisfy the 4 inequalities are. Them say, and shade and label the region that satisfy the 4 inequalities are. So I want us to shade it and label it. Shade it and label it are. So the 4 inequalities, what are the lines? It's 4 of them, you know. These 3 up here and this one down here, right? 4 of them. All right. Let's talk about them. Let's talk about them individually. What each of them mean. So we can represent it on the graph. This one first. First one. Since the y over here is positive, the greater than means above. So going above the line. The equal is a part of each of the inequalities, so all the lines will be drawn solid, unbroken. So we want to go above. We're going above. A solid. And with solid line? Solid line, which is x plus y equals 8. That's how we're going to represent this inequality. The line that is associated with it is this one, and the greater than means that we're going above the line. Why is it? Because the y over here is positive, the greater than means above. When the y on the left side is positive, the greater than means we're going above the line. This one now, the y over here is positive, but we have a less than. So for this one now, the less than means below. So we're going below this line. The line is drawn solid because the equal is there as a part of the equal. So we're going to draw a solid line. If the equal was not there, we would draw a broken line. The line that we draw is the line y equals x. Y equals x is associated with this inequality. And then for this one now, the less than means below. And the line associated with this one is x equals 9. So going below, the line again is solid. And that line is x equals 9. Now x equals 9 is a vertical line, right? Y equals x is the line over like so, right? And x plus y equals 8. Crosses the y-axis at 8 and crosses the x-axis at 8, like that. All right? X plus y equals 9. Then let's do this one down here now. Let's do this one. Let's do this one now, over here. The y over here is positive, so the less than means below. So going below this line, below. The line is drawn solid because the equal is a part of the equal. So we're going to draw a solid line. The line that we're drawing that's associated with this inequality is 2x plus 3y equals 30. Let me shift this over a bit. Let me shift this over. Let me shift it over to show some stuff that we're going to do. Now, I want to be able to plot 2 points on this line. The way to plot 2 points on that line quickly is to put on 2 points like this. One of them are going to make the x value 0, and the other one are going to make the y value 0. All right? That's how you plot 2 points quickly. One of them are going to make the x value 0. The x value 0 is on the y-axis. And the one that they make the y value 0 is on the x-axis. But the one that I'm making the x value 0 right here, it means that it's going to make this value 0. And I'm going to be left with 3y equals 30. Let's look at it carefully. Let's go again. The point where I'm making the x value 0 is going to make this become 0. And I'm going to be left with 3y equals 30. If 3y equals 30, then the y equals 10. So when the x is 0, the y is 10. So a point on this line is 0, 10. At the point where I'm going to make the y value equals 0, then I'm going to put the 0 here for the y value, right here. So this is going to be gone. I'm going to left with 2x equals 30. If 2x equals 30, then x is 15. So at that point, it's going to be 15, 0. So that's how we can quickly find 2 points on the line, on these lines. So I want to draw these lines on the graph. So I want these lines up here. I want this one as well. All right? I will say what I want below the line or above each one. Said it. We have said it. All the lines are drawn solid, but the equal is a part of all the inequalities. All the lines are drawn solid. All right, let's look at the graph that they gave us. So they give us the graph and it's already scaled, right? It's already to scale. So the first line we're going to draw is this one. X plus y equals 8. That line is an easy line. We spoke about it earlier. Crosses the y-axis at 8 up here, let's draw it in blue. And crosses the x-axis at 8 down here. So it passes through points where the x and the y value are to 8. So it also passes through 4, 4, right? Let's use a ruler and draw it, right? Let's use a ruler and draw that line. Then you label the line with the equal sign. X plus y equals 8. Then I'm going to put an arrow pointing up because I want above it. I want above the line. So to remind me that I want above the line, I'm going to put an arrow pointing up at the end right there. Right there. That reminds me that I want above the line. So the reason that I want is somewhere up here, so above the line. I don't want under here. I don't want under here. I want above the line. Next line to draw is the one y equals x. And we want below that line. I'm going to draw a line y equals x. Y equals x is another easy line. Passes through the point 0, 0. It passes through 1, 1. It passes through 2, 2. It passes through this point 4, 4 as well. Right? So it's a line passing right down the middle of the graph, like this. Passing through all those points where the x and the y value is the same. All right, so that is the line y equals x. Label the line with the equal sign. Y equals x. And we want below this line, right? We want below this line. See here? We want below that line. Inequality suggests that we want below this line. So I'll put the arrow pointing down at the end here. So far, I want above this one, and I want below this one. So the region that I want is somewhere in here. So far, I'm narrowing down to get the region. I want a region that's below this one and above this one. So it looks like my region is somewhere inside here. But I need to put in the other two inequalities. The next one to put in is the line x equals 9. Right here. X equals 9 is a vertical line. And I want to go below that line. And I want to go to the left of that line. X equals 9. Let's put in x equals 9 on the graph. So it's 9 here, so this is 9 right here. I want a vertical line through there. So this is the line x equals 9, this line. Passing through the 9 down here. Alright, and I carry it all the way up here. X equals 9. This line. And if I extend it all the way out here, and label the line with the equal sign. X equals 9. I put the arrow pointing this way to mean that I want to the left of this line. So the region that I want right now is somewhere inside this triangle. Because it is below this line, above this line, and to the left of that. So the region that I want is somewhere inside that triangle. We have one more line to put on the graph, which is this one down here. The 2 points that we're going to use. 0, 10 on the y-axis, 15, 0 on the x-axis. 0, 10 on the y-axis. See there, 0, 10 up here. And 15, 0 down here on the x-axis. 15, 0. So just use a ruler and draw the straight line through these 2 points. Like that. So I don't have any rule lines. I'm drawing my best straight line that I can draw. Looking something like that. Alright? It must also accurate, you know. But something like that. You use a ruler, you get it good, right? Use a ruler and get it good. Alright, so I'm not gonna get it exactly accurate because I have it past 2 years. That point is 6, 6. 6, 6 work on this equation. Put 6, 6 work on this equation. Let's see 6, 6 work. 2 times 6 plus 3 times 6. 2 times 6 is 12. 3 times 6 is 18. So it pass through 6, 6. So pass through 6, 6 as well. So let's go. Pass through 6, 6. Pass through 6, 6 right here. Pass through this point. Alright, pass through 6. Let's see where the cross is now, where x equals 9. Where x equals 9. Where x equals 9 on this line to be 2 times 9 is 18 plus 3 to 5 equals 30. So to be 3y equals, so 9 is 18. This is 12. 30 minus 18 is 1, so 12. So the y equals 4, right? So it pass through 9, 4. Let's see. Pass through 9, 4. Right here. Alright, so those are some points on it. So this calculates. Pass through that. Pass through that. Go all the way out. But if you just use the ruler between these 2 points, we'll get it. You have to be calculating it as I'm doing. Just because I have to be drawing with my free hand. All right, so you pass through these points. I want below this line. Label the line with x with the equal sign. What is it again? It is 2x plus 3y equals 30. 2x plus 3y equals 30. Label the line. Don't put any inequality on the label. When you label the line, don't put any inequality. Put the equal there. And we want below that line, right? Below. We want it below that line. So going below this line as well. So the region that we want, you know, guys, is inside here now. That's the region that we want. Then just shade it and label it with the R. Then label it with the purple R. Right in here. Label it to the R. Shade it and label R. So the region that we want is inside here. Shade and label. Never say that here. Now we just ask to shade or ask to label. It's time to shade and label. That is the region that we want. It satisfies all inequalities. Alright? Satisfies all inequalities. Alright, so let's continue. The question says, determine the two combination for the minimum number of cars and minivans that can be used to carry exactly 60 persons. So remember that this was the line that accounted for the 60 persons. And anything you do in these questions, you want anything minimum or maximum, you have to go to the vertices. The vertices. So the two vertices on this line are here and here. And they want two combinations. See? The two combinations. They want those 2 points that will allow you to carry the 60 persons. Minimum of 60 persons. Alright? So basically, 2 combinations they want are those 2 vertices. Now this one is, this point is 6, 6. This point is 9, 4. So 6, 6 and 9, 4. 6, 6. And 9, 4. Those are the 2 points that will allow you to carry exactly 60 persons. Exactly 60 persons means that you're on the line. With the values add up to 60. Understand? You're on the line. Because this line was actually 4y plus 6, 4x. It was actually 4x plus 6y equals 60, you know. So if you want to get exactly 60 persons, because the car carries 4 persons and the van carries 6. So I will simplify the equation down to this. But this is a line that represents carrying 60 persons. This line. So if you want to carry exactly 60 persons, you need to use the combination on that line. And these are the 2 vertices that you can use. All right? To determine which one you carry 60 persons. Right? You carry 60 persons. Determine the 2 combinations for the minimum number of cars and minivans that can be used to carry exactly 60 persons on the tour. So 6, 6 and 9, 4. 6, 6 and 9, 4. Carry exactly 60 persons on the tour. Right? Anything under that you carry less than 60 persons. Anything under here, so you carry less than 60 persons. But the values won't be on this line. Won't be on this line. All right, let's see what they want to say. They said the company charges $75 to rent a car, $90 to rent a van. Show that the minimum rental cost for this tour, and this is tour where you carry 60 persons, is $900. $900. So let's look at it. Remember, these are the 2 points that you can use to carry 60 persons. So you want to know which one of them will basically allow you, which one of them will allow you to have this minimum of $990. Remember, this means 6 cars and 6 vans, you know? And this means 9 cars and 4 vans, right? Understand? But let's write an expression first for the amount that you pay based on this information. It says the company charges $75 for a car and $90 for a minivan. So the charge, let's call the charge C. The charge. C is going to be equal to 75x plus 90y. That's gonna be the charge to rent X cars and Y vans, right? So if you're using this 66, using 66, the charge using 66, the charge is gonna be 75 times 6 plus 90 times 6. You work that out. If you're using, if you're using 9.4, that's what the charge would be. Using 9.4, charge is gonna be 75 times 9 plus 90 times 4. I wrote that out. You want to see which one of them is the lower one, the minimum. We carry this exactly 60 persons. So we're talking about the tour we're carrying 60 persons. So that one give us the 990. So it's 75 times 6 plus 90 times 6. Okay, this will give us 990. And this other one, what will be the charge? It will be 75 times 9 plus 90 times 4. It's giving us 1,035. So the one that we're gonna give us the minimum charge is the one who carries 6 cars and 6 vans. Right? So it said, term show that the minimum rental cost is 990 right here. This is it. So the minimum is $990 when 6 cars and 6 vans are rented, are used. That's it. Good? That's it. So that's that question. It's a nice question. I like it. All right, so that's the 2 paper, the second paper. All right, let's go now and do the 3rd paper. People online okay? People online
Yes, sir.
okay? All right, good. Let's go on to the 3rd paper now. 3rd paper, number 8. That's what they give us in 3rd paper. So the number 8 is not consistently one topic, guys. Right? The topics vary on number 8. That's why number 9 and number 10 are sure topics to prepare for. Number 8. All right, so this number 8 is a quadratics again. See there, number 8. It's a quadratic function again, right? Let's look at it. Well, this one is going to be a frown quadratic. You see the x squared there, negative, so it's going to frown. But the x squared is negative, so it's going to frown. Again, it's a quadratic graph. It has an axis of symmetry, or line of symmetry, and it's a vertex point. Right? So I see a 9 and a 9 here. I know that my axis is right in between here, so. Right in between the 2 and the 3. So my axis point is where x equals 2.5. That's my axis of symmetry, right between the 9 and right between the 2 and the 3. So we want to find that the vertex value, the maximum value, I plug the 2.5 in the function, and I can work it out. Y equals 3 plus 5 times 2.5 minus 2.5 squared. The question I asked me for this, but I know that I need it because I'm going to draw the graph properly. All right, so work that out for me and tell me again. Work that out for me and tell me again. Supposed to be something greater than 9, like 9.25 or something. Work it out now. My axis of symmetry is right here. The values are symmetrical about that line. The values are symmetrical about that line. Y values are symmetrical about that line. But again, must be 9 point something, something more than 9. Huh? 9.25. So it means that the maximum point is at 2.5, 9.25. This is your maximum point. The maximum point is right there. It's not on the table, but we need it to put it on the graph. All right? We need it. Now look again. The values are symmetrical enough. The values are symmetrical. So let's see if we can pick out the values. So we have 9 and we have 9. And then And then 2 places down after the 9, we have 3. So this right here is going to be a 3. We could actually know it's a 3 by plugging the 0. Plugging the 0 in the function for the x there. It's going to be a 3. So that's not really a giveaway. So it's going to be a 3. Then now we'll find is that to the right of the 3. Oh, thank you. Just got a Teacher's Day gift, guys. Thank you very much. All right. So to the right of this, to the left of this is -3. So the right of this is -3. So I know that the value over here, right here is 3. And right over here is going to be -3. Just as well. To the right of this is -3. To the left of this is -3. The values are symmetrical on either side of the axis of symmetry. Remember that, right? I could calculate it by plugging the 6 inside here. Why do all of that when you can just use the symmetrical nature of the function? Now, if I find the value for 1, it's gonna be, and get this value here, it's gonna be the same value there for the 4. I don't work out both of them. So I just need to calculate the value for 1. So I'm gonna plug the 1 inside here and there to work it out, right? So when x equals 1, y is gonna be 3 plus, this becomes a 5. 5 times 1 is 5, minus 1 squared is 1. That becomes 8 minus 5, which is 7 right here. So this also is a 7. If you want, you can check it by plugging the 4 in there. If you want, you can check it. It's also gonna be 7. But the function is symmetrical. So those are the values in the table now. All right? Ready now? Say they want us to fill out the graph, complete the graph. So you see they give us some of the points already. We need to fill out the ones that they didn't give us. Now the line of symmetry is right down here now, guys. Right down the middle here, so. So the values are symmetrical. Right? So for example, this is what? How many units to this? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is going to take me to a point right here as well. All right? 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, that's how it works. All right? Going to take me to that point. But let's look at the graph still. Let's not get ahead of ourselves. Let's put on the points. All right. So the points that we're missing, the points that are missing, 0, 3. 0, 3 is right here. Same point that I just marked the one. 0, 3 is right here. Right? Next point that is missing is 1, 7. 1, 7. 1, so 1 here. This is 7 right here. So we're talking about this point. 1, 7. Right? And it's going to be symmetrical to over here. Here is going to be a point as well. But let's follow the table. Then we're going to have 2, 9. These two are on the table. We're going to get 4, 7. 4, 7. 4, 7. So 4 here, 7. So it's symmetrical. This point. 4, 7. Everything is symmetrical about this curve. The last point that we don't have is 6, -3. 6, -3. Corresponding to this all the way out here. 6, -3. All right. So 6, -3 is right here. Remember, we worked out the axis of symmetry point is 2.5, 9.25. So we need to put this one in. They didn't give us. Put it in there. Right? Put on that point. So let's look at the scale. This is 9. Let's look at the scale properly. Put on in red. I have to check it properly. This is 9, right? That is 9. So that is 9. And this is 10. It means that right here is 9.5. Okay, for 9.25 is halfway between here and here. So it's about right here, don't it? About there, don't it? Above this. Actually above this, about here. So 9.25 is about on this line up here. So right here. So we draw the graph, we need to make it turn over there. So that's where it's gonna turn. This point. That you can't come and draw the graph straight across there. You must go up and turn. You understand? So that's vertex point. Let's draw the graph now. So let's draw the graph now. Smooth curve through those points. Zoom it up. Coming down here. going down here. The same thing on the next side. Come through here. And come all the way down here. That's my sketch. All right? Very important that you identify that vertex point up there, guys. The axis of symmetry is this vertical line down here. The vertex is at the top of that axis of symmetry on the graph. All right? It's a prone graph. All right, so that's the graph. All right, and that's what they wanted us to do, to draw the graph, right? Draw the graph. Next point, so write down the equation of axis of symmetry. See, the axis first. Vertical line through the middle here. Halfway between 2 and 3. So x equals 2.5. X equals 2.5 is the axis of symmetry. And then it says state the maximum value. See it? 9.25. So I didn't even know that I asked for it. I just knew that I needed it. 9.25 is the maximum value. That is it. But okay. Different question now, right?
Yes, sir.
No, that's different. It's the same question on another part. They say, write on the coordinates of the point where this line was the x-axis. On the x-axis, y is going to be equal to 0. So we're going to plug the 0 here. So we're going to say if y equals 0 here, then the 3 minus half x is going to be equal to 0. And so the x is going to be equal to 6. That's all. Because half of 6 is 3. See? 3 minus 3 is 0. So the x is 6. So that point I'm talking about, therefore, is 6, 0. Let me put it in blue. So the point is 6, 0. 6 is the x value, y value is 0. You know what is the point where it crosses the y-axis? It crosses the y-axis where x equals 0. On the y-axis, x equals 0. So plug in 0 there. We're going to be left with y equals 3. All right, so we're going to get y equals 3. So it means that the point is 0, 3. 0, 3 is the point. Those are my answers. So this is an answer. This is an answer. So it passes through this point and this point, right? 6, 0 and 0, 3. Them say now on the grid we must draw the line. They help us by giving us these 2 points first. 0, 3 and 6, 0. They want us to draw the line on the graph. Let's go on the graph and draw it. So let's draw it in the red. So what did we say? 6, 0, wasn't it? Which is here. And 0, 3. 0, 3 is right here. 0, 3. So it passes through this point as well. So use the line and draw the graph. So we can actually use the gradient too now. The gradient is minus half, right? So to get it a little bit more accurately, we can rise negative 1, 1, 2, right? Rise negative 1. Oh, let's make sure the scale is correct. And the vertical axis is 1 to 1. On the horizontal axis is 2 centimeters to 1. See that? So we're using a gradient of minus 1 over 2 to get other points. We could just draw the straight line through them points now with a rule line like that. But I'm showing you how you could get other points. So it's rise negative 1, run 2. 2 takes me all the way to here. This point. Rise negative 1, run 2. 1, 2 takes me all the way to here. Rise negative 1, run 2 takes you all the way out to there. Take it back to the same point. So the graph that we want passes through all those points. All right. You could just use a ruler with these 2 and get it. All right. So it's going to go like this now. Straight line through those points. All right. So that is my line. That is my line. Question says now, use a graph to determine the solution of the equations, this and this. So the solution of these 2 equations is where the 2 lines curve, the curve and the line intersect. They intersect at these points are going to mark in purple. They intersect here and there. Those 2 points are intersect. So this point is clearly 0, 3, right? So no, 0, 3 for sure is one of them. So one answer for this is the point 0.03 on the y-axis. The question now is this one. I want to get this one now. You have to just tell them what you get. I'm going to say 5.5. I'm going to assume that it is right here. I'm going to assume that it is right here. 5.5, and that will be one. Now look at this one. Look at the scale. Each of these lines is 0.1. Each of these small lines is 0.1. This is 1. So it's blue. This is 1. So this is 0.2, 0.4, 0.6, 0.81. So this line is 0.2. This is 0.2. Not 0.5, 0.2. This line is 0.2. So I'm going to say it is 5.5, 0.2. That's what I'm going to say based on what I get. Don't have to be the correct answer precisely, but you have to tell them what you get on your graph. So it's 5.5, 0.2. I'm going to give them based on this graph. 5.5, 0.2. All right? That's what you get. Because this graph is not drawn accurately. You can't get the precise point where that graph passes through. So it's 5.5, 0.2. I'm going to give them 5.5, 0.2. All right? Give them what you get. 5.5, 0.2. If you like, you could plug the 5.5 in here and see what y value you get. Do that as well. Plug the 5.5 in here. Let's see what we get. Just to kind of double check it and see what we get. So if I plug the 5.5 in there, it will be 3 minus half 0.5 times 5.5. 0.25. So let's put it 0.25. 0.25. So at least it is consistent with the line. I'm going to give them that. 5.5, 0.25. 5.5, 0.25. That's what I'm going to use. But good with that? But okay with that? All right?
Yes, sir.
Yeah, so the number 8 can require some work sometimes. Number 8. Right? All right, let's look at the number 4 people. Number 4 people. Number 8 and the number 4 people. Here. See another quadratic graph. You see? Like to do quadratic graphs. Another one. See? Another quadratic. This number 8. This is a question that CSEC messed up in. They gave the wrong scale. See? They gave. I remember this question. They messed up the scale on this graph. Yeah, because this is 1, 2, 3, 4, and I put 5 right here. And up here now, 15 to 5 is 1, 2, 3, 4, 5. So the scale is inconsistent. And here now is 1, 2, 3, 4 to give you a 5. So the scale is inconsistent. What I was saying to the students, if I recognize that, I'm going to adjust it on the paper and put this as 4. I'm going to do like this and put this as 4. But this is actually 4, not 5. 5 would actually have to be right here. You understand? So I will maybe adjust it and put the 5 right there. So erase these and put on the correct scale. And erase these as well. And put on the correct scale. So let's do that. So right here will be 5. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. I don't even know that it will help because maybe the scale messed up. Erasing by the points. So these things that mean CSEC sometimes, you know. Right? And then up here now, I'm going to put on the correct scale again. 1, 2, 3, 4, 5. 5 will be right here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 11, 12, 13, 14, 15, 12, 10, 11, 12, 15. So that's a better scale. 1, 2, 3, 4, 5. Let's see if this can help us. All right, let's see if this can help us. This question says, Marla buys two, this is another linear program. Marla buys 2 types of phones, B phones and C phones, B Flow and C Flex. I'm just going to call it B and C, from a company to retail. One B phone is for $60. So the B phone is right over here. The B phone is for $60 each. And the C phone, is for $80 each. The C phone, all right, $60. $60 for a B phone, $80 for a C phone. And so she buys X number of B phones, so X phones she buys, X phones. And she buys Y number of C phones, so buy Y number of C phones. That's the information. So I just basically put the information here and drop it here so I can see it in front of me. So this is the cost for the C phones, and this is the number of B phones. B phones are, this is the cost for the C phones, and that's the number of C phones. All right? So Marla must not spend more than 1,000. Must not spend more than 1,000. All right? Huh? 1,200, yeah. She must not spend more than 1,000. So she can spend that amount or less. She can spend more. So total amount she spend must be 1,200 or less. So the amount that she spend is 60x plus 80y. See that? So 60x plus 80y has to be less than or equal to 1,200. She can't spend more. She can spend 1,200, no, that's not more. So it's that amount or less. This can be divided through by what? Divided through by 20. Divide through by 20. So I'm going to divide through by 20 to simplify it. Divide through by 20. Divide through by 20. This becomes 3x plus 4y less than or equal to, this becomes what? 60? 60. So that is equal. 3x plus 4y equals 60. Next part says, the number of B phones must be greater than or equal to the number of C phones. What's the number of B phones again? Is X, right? X must be greater than or equal to the number of C phones, which is Y. Y. Write an equal to represent this information. X must be greater than or equal to Y, but I like to have Y on the left side. So I'm going to switch it around and write Y less than or equal to X. But this now would mean below the line because the Y less than means below. Remember, less than means below only when the Y is on the left side of the inequality. So plenty of persons might use this and figure that they're going above the line. And this line is related to Y equals X. That inequality is related to Y equals X. All right? So we're going to go below that. 1 mark for that. All right. Represent the two inequalities on the grade below. Label as R the region which satisfies both inequalities. So we want to put the two inequalities on the grade. So the first one up here is this. We need 2 points on it. We know that we're going to draw a solid line because the equal is a part of inequality. We're going to go below the line because the y is positive, so less than means below. And the line that we're drawing is 3x plus 4y equals 60. So again, we need 2 points on that line quickly. 2 points on the line. I don't know if it will work because we have to adjust the scale or whatever, right? So we need a point where the x value is 0 and a point where the y value is 0 and work it out. So where the x value is 0 right here, we're going to have 4y equals 60. If 4y equals 60, then the y value is 15. So this is 15. Then put in y equals 0 right here, we're going to get 3x equals 60. If 3x equals 60, the next value is 20. But 20 is not on the scale that we're drawing. 20 is not on, is it? So we have to use a different value. So let's use 15, for example. So it's 15, Let's see what the y value is when x is 15 on this line. Up here. So let's put it on the line. This line, when x is 15. So when the x equals 15, the equation here becomes 3 times 15 plus 4y equals 60. This is 45, right? 45 from 60 leaves us with 50, don't it? So when I have 4y equals 15, 15 divided by 4 is how much? 15 divided by 4, quick. 3.75. 3.75. So 1 point is going to be 15, 3.75. I'm going to try and see if we can draw, right? At this point, we can get 0.50. That's on the graph. 0.50. Sit there, 0.50. All right. Another way we could do it to put in form y equals mx plus c and use the gradient. Rise over run, right? Could do that as well. All right. Let's draw this line now. Let's see if we can draw this line. So pass through 0.15 on the y-axis, which is right here. Then we pass through 15. What if 10 would work better? 10 something. Yeah, 10 is going to work better. Let's see if 10 would work. X equals 10. X equals 10 right here, so we're going to get 30. 3 times 10 is 30. We're going to get 30. Still not going to work, don't it? Yeah, man, going to work. We're going to have 30 divided by 4. No, still not going to get a whole number. Eh? Still not going to get a whole number. What's that? We're going to use this one. We're going to estimate this one. 3.75 and draw it. So this is 1 point. The next point we're using is 15, 3.75. 15, 3.75. That's because CSEC messed up the scheme. So this is 1, 2, 3. This is 4. Good? 1, 2, 3, 4. 3.75. So if we zoom it up, 3.5 is here, don't it? 3.5 is here. So 3.5 is somewhere inside us. So, don't it? So we're talking about inside here. 3.75 all the way over to 50. So we're talking about somewhere about here. It's 3.75. 15, 3.75. Right? So we're going through those 2 points. So you do something like this. You do something like this. Let's try that again. Use a ruler and draw, right? That is the line. I want to go below that line, right? Below that line. The next line to draw is y equals x. We're going below y equals x as well. Y equals x kind of easy. If I pass through 0, 0, pass through 5, 5, pass through 10, 10, which is up here. All right? So that line will go like so. Right on the middle of the graph, like so. And this is y equals x. Let's label this one. This one was what again? 3x plus 4y equals 60. This one was 3x. Let's leave it up here. So 3x plus 4y equals 60. We're going below both lines. Below both lines. So the region at our moment is inside here. So that's the region at our moment. Below both lines. Let's see the one to shade out. The questions are represent inequality. Label R, the region which satisfies the both inequality. So R. Below both lines. What else do they want us to do? So the total number of mobile phones is represented. Total number of mobile phones represented by x plus y. It says, according to the graph on page, what is the largest possible value of x plus y? Largest possible of x plus y. You basically come to a vertex. If a vertex cannot work, you go along the side. Now, why this vertex can't work? Because you don't have a whole number of phones. You understand? You cannot have a fraction number of phones. So you can't use the vertex, so you go along the side. No point along this side will work as a whole number. So you come along this side to here. So we're going to use this point right here. If a vertex cannot work, you go along the side. That point is what? 8, 8. 8, 8. That's the largest number of phones that you can have. 8 and 8, the largest square. So this answer is 8, 8. You cannot use a vertex, you cannot have 8.5 cones and 8 3/4 cones. This point is not a whole number point. All right, the CSEC allow you to draw the graph properly, you will see it more clearly. But that is it, right? That's not a whole number of folds. That is it. 8, 8. Next question. Next question says the table below shows a pair of values of functions. That's a quadratic again, and I give you all the values this time. Give us all the values this time. We don't have to work out anything. It's gonna be a smile shape, right? Let's leave the axis of symmetry. Axis of symmetry is right between here again. See, it's the same thing all the time. The axis of symmetry is right between here and here. Between -1 and 0. That's -0.5. So the axis of symmetry is where x equals -0.5. Let's work it out. X equals -0.5. That's the minimum point, right? Minimum point at a vertex point. You have to work it out because they don't give it to you and you need to put it on the graph. I'm going to put the -0.5 in the function here and there. Right? So the y value is going to be -0.5 squared for the x, and then plus the -0.5 can as well, -0.5 minus 0.5 minus 4. Where that all from? Somewhere below the 4, -4.25. Work it out quick. That's 0.5 squared minus 0.5 minus 4. -4.25. So the point is -0.5, -4.25. That's a vertex point. You need it for your graph. Just don't give it to you, you have to work it out. All right? It's right between you, the axis line. Divide the graph, divide the values equally, left to right. All right? So let's see. So it says write down the maximum value. So it's not a minimum value, it's a maximum or minimum value. It's a minimum because it's a smile graph. So you can cross this out and say it's a minimum, right? Minimum value is this, -4.25. You can leave this calculation on the paper and you can penalize it for writing it on the paper. It's minimum value. Minimum equals -4.25. It's a minimum y value in the graph. All right, next bar is a minimum, not a maximum. So crossing out the max, it's a minimum. Next bar says using a ruler, draw the axis of symmetry of the graph. So it's this line we're drawing, x equal, right, so x equals 0.25, which is right here, -0.25, right here, right? So drawing this line, that's the axis of symmetry, -0.5, this axis of symmetry right here. So that is x equal -0.5. All right, and then them say now draw the axis of symmetry. Do they want us to complete the graph? Did they say complete the graph anywhere? So on the grid, plot the remaining 4 points and draw the graph. So plot the points and draw the graph. All right, so the point was, the minimum point was -4.25, right? Let's position it properly. So that and that is -1. So this will be -5, right? So -4.5 we right here. -4.25 is about halfway there, don't it? So talking about this point, that's where the minimum point is, right? And then the values are symmetrical. So for example, this one symmetrical across from this. This one didn't show us. That's a point on it. And this is 3 units to the line. It's going to be 3 units over here to here. Right? You can see it. Right here is 1. The next value across takes up to there. The next value across takes you up to the same place here. Up to the same place here. Everything symmetrical. Right here is the next value. And then the next value cross take you all the way up to here. Cross take you all the way up to the same place there. But the values are symmetrical. I don't need to waste time and plot it. The mathematics is the easy way. The graph is symmetrical. All right, I need to draw the smooth curve through them. Let's use the fluid. Smooth curve through the points. All right, so I'm going to come down. Remember, though using a ruler on it, it's a curve. See? Some persons, when they do it, they come straight across here because they didn't calculate that point. You have to calculate that point, guys. You have to calculate that point. And I'm coming down on the other side, symmetrical. Symmetrical, coming through the points. Wow. You have started to wobble. Good enough, that is it. All right? That is the graph. That's the axis of symmetry right here. That's the minimum value down here. Negative 4.25. What does I want us to do? Draw the axis of symmetry and question done. That's it. It's now 3 o'clock. We basically just have one paper to do. One more paper. Do one more paper, I'll call it a day. So tomorrow starting at 5 o'clock. Instead of 9, we're going to start at 5. Yeah, here. Come in here. I'm going to set up the projector and set up the thing and just do another thing at 5. So people online will start at 5 p.m. tomorrow. Okay? 5
Yes, sir.
p.m. starting tomorrow. We're going to do the remaining questions and the papers. All right, topic by topic. So let's look at paper number 6. Paper number 6. Paper number 6, January 2020. Number 8. Number 8 and paper number 6. Let's see what they give us. All right, last time graph. Functions. All right. Right here. Question says, solve the pair of simultaneous equations. This is a line, that's a curve, and that's a line. So the two of them equal x. So all it means is that we can basically make this substitution for the x right there and get a quadratic in y first. So I'm going to substitute for the x. So these two are going to give me that y squared plus 2y plus 11 equals, I'm going to replace this x with this. Because at the point of intersection, two x values are the same. So you can take this and replace the x value there. All right? Because the line is saying that the x is equal to this. So I can put it there so for the x. All right? So I'm going to get 5 minus 3y. So it means that I'm going to calculate my y values first. So I have to be careful when calculate y values first. I need to transpose these two over here. I need 0 on the right side. So I'm going to get y squared. This 3x come over and add to that and give a 5x. 5y, sorry. This 5 come over here and subtract, give me 6. Equals 0. These are friendly values. But the factor of 6 that add to 5 is 2 and 3. So I'm going to factorize it. I'm going to get y and 2 and 3. Signs are the same. They are both positive. Positive, positive. So those factorize nice. So this factor give me y equals negative 2 equals 0. And this one give me y equals negative 3. Then to substitute these values up here now to get the x value. All right, so this one, the x is going to be 5 minus 3 times negative 2. But substitute the negative 2 here. All right, this is a positive 6. 6 and 5 is 11, so x equals 11. So 1 point down here, so is 11 negative 2. Remember, if we put the x value in the bracket first. So even though we calculate the x value second, we still put it first in the bracket. That's 1 point. The other point, I'm going to substitute the negative 3 again in here. So I'm going to get y equals 5 minus 3 times negative 3. This minus is a plus 9. I'm going to get y equals 14. 5 and 9 are 14. So this is going to give me the second point. Not y, no, it's x. Not y, it's x, I'm fine. X. X. X, X. So the x value is 14. And the y value is negative 3. So that's my solution. Those are my answers. Quick and fast. This and this are my answers. Quick and fast, nice and easy. Solve them simultaneously. All right? 4 marks for that. Let's continue. Then we have a functions question right here. All right? What did it say? It's a quadratic function training. They want us to complete the square right in this formula. I don't know what people on the class learn on the Zoom. People learn b over 2a for the h. All right, so let's use that. Since it's a plus, you can use the h equals b over 2a. All right? If you're using the x minus xt method, squared plus yt, then the xt will be minus b over 2a. But the difference that we have a minus here as compared to a plus. See that? That's what happens. So if you're using the plus h, then the h is b over 2a. Understand? All right. So from this up here now, you get the a and the b from this standard form. So the a is 4, the b is -8, and the c is -2 from this, right? Coefficients up there. Note I did not leave off the sign, the -8 and the -2. So I'm going to get the h right here now. So the h equals, the b is -8 over 2 times a, and the a is 4. So the h is -1. And then now, so when the h is a whole number like this, is that? Forget about it. You could plug it in there so I find the function. Because this is over actually the y value at the turning point. That we calculate the xt. All right, but anyway, let's calculate the k now. The formula for the k too. 4ac minus b squared over 4a. Same formula. All right, k equals that of using that method. Same as the yt. Same thing. So the k will be equal to 4 times a, which is 4, times c, which is -2, minus -8 squared, all over 4 times a, which is 4. So this guy want to write that down. All right, I'm going to use my calculator and I'm not going to kid myself. There's a calculator in the exam. So I'm going to put it in the calculator as it is there. I kill self. You can put it in the calculator. This is a fraction. It says 4 times 4 times -2 minus -8 squared. Eh? 4ac. Oh, 1/2, sorry, -2. Yeah. This -8 squared is 64. Now, can I try 64 there? Over 16, not it? 4 and 16. That's all? So I get -6. Now, as I tell you, you could have plugged this h back in here, so you know. You get -6 CMA. This is the x value turning point CMA. No, I lie. It's not xt. Our method will be xt, it will be different. Xt will be equal to 1. So it's different. So forget that. But we're not using xt and yt. We were calculating xt, we plug the xt value. The xt will be equal to 1. We will be saying x minus xt. You understand? So that's exactly that. So basically, dropping the values in here now. Let's put back this. So we can write back this function here. So now this. Right back over here now. So f of x becomes equal to the a in front, which is 4, into x, and the h is -1. Don't forget the square, and the k is -6. So -6. That is it, right here. All right. State the minimum value. The minimum value is -6. Let's write it down. -6. Minimum value. Determine equation of axis of symmetry. No, the equation of axis of symmetry is x equals 1. That's why I mean like x, t, y, t. Axis of symmetry is where this equals 0. So it's x equals 1. It is the x value at the turning point. So it's when this equals to 0. So it's when x equals 1. X equals 1. If I use the xt method, then I will get xt is minus b over 2a, and it will come out to be 1. And it will be axis of symmetry is x equals 1, is it? And there's no confusion. Not do it that way. That's why I prefer that way. But let's do this simple process online, because person online would not have learned x, t, y, t. Understand? Good. So let's do it that way. So x equals 1. Basically, when this equals 0, give you axis of symmetry, right? X value there is the x value at the turning point, which is when the bracket term equals 0. All right? That is that. All right, x equals 1, axis of symmetry. Then we'll come to this velocity time graph or speed time graph. Question says, the speed time graph below, not drawn to scale, shows the 3-stage journey of a car over a period of 40 seconds. Determine the acceleration of a car for each of the following stages. Stage 2. Stage 2, gradient of that horizontal line is 0. Remember, gradient is acceleration. So in stage 2, the acceleration is 0 meters per second squared. The acceleration will give them the unit. I can write it like this, meters per second squared. Acceleration on stage 2 is a gradient on stage 2, the gradient of a horizontal line is 0. It is not accelerating because the speed is constant. So the speed is not changing. All right? Next part, I want at stage 3. That's for the acceleration. So since I want the acceleration, we have to give the negative this time. We don't want the retardation, we would leave it to the positive. We don't want the acceleration, so you have to put the negative on it. So this has a negative acceleration. So it's rise, but the rise is down, overrun. See that? So the rise is 12. No, it asks us for acceleration, so we have to put the negative on it this time. That asks for retardation, we would not put the negative on it. But this now has negative acceleration. Understand? So the rise is negative 12 and the run is 8. See that? So this becomes rise over run because we're trying to calculate acceleration. So it's negative 12 over 8, which is what, 1.5? Negative 1.5 meters per second squared. And so, yeah, 1.5. 12 is 1.5 of 8. Negative 1.5. And that finishes that question. All right, so we're gonna stop it there for today, guys. This was a quick and fast question to do. I'm gonna stop it there. They didn't ask us for no average speed and just acceleration, no water, and two stages and done. No distance, no nothing. That's it. All right, that's it. But online, okay?
Yes, sir.
All right, so remember tomorrow we're gonna start at 5 p.m. instead of 9 p.m. 5 p.m. We'll start at 5 p.m. Same setup. I send out the link again, and you can same Zoom login at 5 p.m. tomorrow. And we'll continue with the same 6 papers, working all the questions for revision. All right? Bye, everybody.